Following this video, we're going to go talk about these three standards here because I do think it's important to know all the three because that's the real way you're going to really get APIs into here. You're not really going to be doing it manually. And then the last one is really great if you want to spin up an API that you know you want to integrate right away. Very common ones would be app service. Actually, I guess all three of them really, to be honest, Logic App or App Service or Function App. And I'm pretty sure in this we will show you with Function App in the follow along there. So those are some options there just to get quickly started. But let's take a deeper look at these open definition standards for defining APIs and then importing them, starting with OpenAPI. All right, let's take a look here at OpenAPI. So here is an example of one written in YAML. I have a feeling that it can also be done in JSON, but just taking a quick look here, you can kind of get an idea. You have paths. That is an endpoint or a method if you want. The method that to be used would be post here. You can provide a summary description, the contents, should it be application JSON, schema information, and what responses should come back. So pretty straightforward. It gets a little bit more complicated than that, but that is the best snapshot I can provide to you of that language. So OpenAPI specification, OAS, defines a standard language agnostic interface to RESTful APIs, which allows both humans and computers to discover and understand the capabilities of the service without access to source code documentation or through network traffic inspection. And OpenAPI is really the leading one. This is what pretty much everybody uses nowadays. No matter what cloud service provider you go to, they're going to have an option for their API gateway to import OpenAPI. Swagger and OpenAPI used to be the same thing, but as of version 3 of OpenAPI, Swagger and OpenAPI are two different things. So OpenAPI is a specification. Swagger are tools for implementation. For the specification, if you want to use, I think it's like Swagger, it's by BearSmart, and BearSmart, I believe, is the one that came up with OpenAPI to begin with. And so OpenAPI can be represented as either JSON or YAML, as I said earlier, but there you go. Let's take a look at WADL and WSDL. They're very similar. That's why we're giving them one slide together. So Web Application Description Language, WADL, and then Web Service Description Language, WSDL. These are specifications defined by the Web Consortium. Was it W3G, W3 something? W3C probably. And I believe that WADL was originally made by Sun Microsystems. I don't know who made WSDL, but it definitely is under the W3C. And here's an example of WSDL. Very, very, very heavy because it's all XML. Most people like JSON and YAML. That's why OpenAPI is so popular. But just taking a look here at WADL and WSDL, the idea is that you will have some things that are similar. So with WADL, you define an application. For WSDL, the equivalent is definition. Here we have grammars, here we have types, here we have resource, here we have interface, method, operation, request response, input, output, param, element, param, simple type. To me, WADL looks more like like how we would describe in terms of terminology. I cannot remember which one is more advanced because one has more capabilities than the others. But to be honest, you're not going to be using any of these. You're going to be using OpenAPI, but I just wanted to show you them and the fact that you can translate their XML over to that there in this table. So hopefully that gives you kind of an idea. There you go. Let's take a look at the developer portal. So the developer portal is an automatically generated, fully customizable website with the documentation of your APIs. It's where API consumers can discover your APIs, learn how to use them, request access to try them out. So here is an example of the default one that you get. To be honest, I did not know how to use this. I tried really hard because I thought it was a very cool idea. Now this is actually the second iteration of the developer portal. So there was an older one that was different from this, but this is the new one. And I like the idea, but in execution, I'm not sure exactly what to do here. But the idea here is you need to publish, you'll need to publish for the developer portal to be publicly viewable. You can save revisions of the portal to quickly roll back to previous versions. You can apply custom domain for your developer portal. So the idea here is, there's on the portal overview to see it. There's a link there that you click and that's how you view it. Not available in the consumer plan, available in all the other plans. I guess the idea behind the developer portal is like if you're trying to sell a cloud service, but it's API driven, and they just pay to access the developer portal. Or I guess it's also to read the documentation for people that need to utilize it. Yeah, in theory, I like the idea. Execution, I don't know. All right, so there is authentication for the developer portal that you can set. There's a few different ways to do it. You can do Active Directory, B2C, identity providers like Google, Microsoft, Facebook, basic authentication, which is the default version. If you're not familiar with basic auth, the idea is you can enter a username and password that gets prompted to you. So not super complicated. There's also delegated authentication, which allows you to use your own web app sign-in, sign-up process, product, subscription, instead of the built-in developer portal, built-in functionality. And just to figure out where that is, under the developer portal, you have identities. You can add those. You can see there's delegation down below. So not super complicated, but yeah, there is authentication for the API, and then there's authentication for the developer portal. So just make sure you understand the distinction of those two, because it does get a bit confusing. Well, let's talk about caching. So we have a built-in cache and an external cache. So API and operations in the API management can be configured via response caching. When we're looking at policies, we had an indicator as to how caching works. Response caching can significantly reduce latency for API callers and backend load for API providers. So we're going to just provide a caching policy to the outbound or other places. Built-in cache is volatile and is shared by all units in the same region in the API management service. So for that reason, you have the ability to set an external cache via Redis. So that would be using Azure's Redis cache service. So using external cache allows you to overcome the few limitations of built-in cache. So avoid having your cache periodically cleared during API management updates. Have more control over your cache configuration. Cache more data than your API management tier allows. Using cache with the consumption tier of API management. Enable caching in the API management for self-hosted gateways. You simply need to provide a connection string to your Redis cache. So there you go. All right, so after a really long wait, like 40 minutes, and I was able to do like so many other follow-alongs while waiting, this is ready. So very long time, 30-40 minutes. We'll go to the resource here, and so we have this environment set up, and we're going to have to actually have something to route to. And so the idea is that we want to set up a container app. And so before we can go ahead and do that, we're going to need to create a container app. So what you'll do is open a new tab. All right, and we're going to search for containers, and then we have container apps. And so what we'll do is go ahead and open that. And then from there, we'll go ahead and create ourselves a new container application. The container app is a little bit better than container instances. I don't know if this came afterwards or just serves a different purpose, but container apps is pretty nice. So what we'll do is say, we'll create, or actually we don't need to create one, but we'll use the same namespace. So my APIM. And we will call this one my container. Doesn't really matter what we call it. For the region, does this have a region, or is this a global service? It feels like it should be a global service. I don't think we chose a region. It says Central US. I'm just going to stick to the same thing just in case. Just a good way when you're doing labs. And we're going to start with a simple hello world container. So we're just going to make it super easy for us. Don't have to do any coding to get an application running. We're going to go ahead and do create. And so now we just need to wait for that to deploy. It shouldn't take too long, so I'll see you back here in a moment. All right, so after waiting, I don't know, like 4 or 5 minutes, it looks like our environment is set up or our container is deployed. So we clicked into it, and there should be, there it is, application URL. So if we just open that in a new tab, you should see this, and that is what we're going to try to route to for APIM. So what we'll do is make our way back over to APIM. We'll go ahead and create a container app, and here we can go browse and select our container. So to make it super simple for us, super easy, as you can see, I'm going to look at full for a second to see if there's anything interesting there. Nothing that I care about. We'll go ahead and hit create. So yeah, they make it really easy. And so once that's configured, we just need to observe that this API actually works. So we'll give it a moment. Okay, there we go. So after a few minutes, there it is. So let's just test that our API is working now. This web app is an HTML page, so it's not really what we'd want to return, but it's the easiest example that we can set up here. So I'm going to go to the GET request here. And from there, I'm going to go to test. And we are going to see that it's going to send a request here. Notice that it's sending the subscription key. So this is what we normally have to pass along, which is over here. We'll do that in a different follow along here. We'll go ahead and hit send. And we'll give it a moment. And we get some data back. So it's the HTML page. It's what we're looking for. Welcome to Azure Container App. So that is great. So we're done here. We'll keep this environment around for the next few follow-alongs, but there you go. Hey, it's Andrew Brown, and we are continuing on with APIM. And this time around, what we want to do is actually work with some subscription keys, because here we are just hitting the button. That's not how we're going to use our API, right? So let's go over and set up a new product. Before we do that, I'll go over to subscriptions. Let's just show you that we do have some keys here. And notice there's one called service. It came with a product and a limited one, but this service one is actually being used in our APIM. So when we were testing, that was the key that it was using. So if we go back to APIs and we click into our here, my container, and we go to get, somewhere here, if we go around, just gonna click around here, settings, test, down below, send. I think it gives us some information so we'll know what key it's using. So here we can see the key somewhere, or it should tell us. I do know that it's using the service key. I can't remember how I know that, but I know it, okay? And so the idea is that we want to create our own key, I guess, at some point, but we'll go for product and we'll make a new one. I'm going to call this developers. Actually, I'm going to call it junior developers because originally it was developers, but I'm just going to do junior developers just so we're not conflicting. We'll hit publish, so that's okay. And we need to add our API. So here we'll choose my container. We'll go ahead and create it. So we'll just say for junior developers, even though it's going to really have full access. And this is just a way that you can like catalog out your APIs or assign them to different groups. So it's a good way to organize your stuff is to create them in products. And so if we click into here, you can see that there's APIs that's assigned. We can assign policies if we want globally for everything. We can change, we have some settings for access controls, and we have subscriptions. So we do already have the subscription key. We don't have to go and create a new one, but we should probably look at access controls because right now it's just set up as administrator access. We're gonna go ahead here and add another one called developers. I believe you can add or create your own groups. But it's not super complicated, so there's no point in really talking about it. We do want to go get the primary key for this. So here, what I want you to do is click into here. And oops, actually, that's not what I want. There was nothing to change. I don't know why I hit save there. That was pointless. But what we'll do is go back to junior developers here, back in the products here. We'll go to the subscription side here because we need to see the key, which is here, junior developers. So if we go here and say show keys, now I can get the primary key. So we need that key because we actually want to make an API request. And this time we're going to use PowerShell for fun. So I'm opening up Cloud Shell up here in the top left corner. Make sure it's set to PowerShell. It always doesn't hurt to learn some PowerShell. We can do it in Bash, but let's do PowerShell. It's a bit easier to do that. And we'll give it a moment to spin up. If you're doing this for the first time, it might ask you to make a storage account. So you might have to press some buttons here. So just press whatever buttons it wants to get to this part, okay? And it doesn't normally take that long to spin up. There we go. So the first thing we're going to set is a URL. I'm just waiting for it to give me some more information. Yeah, still going. There we go. So we're going to set a new variable. Whoops. We'll type clear first. We'll type new variable. And this needs to be, well, first we'll do our subscription key because we already have it in our clipboard. Subscription key, double quotations, paste that in. It didn't actually grab it. So that's fine. I guess we'll go grab instead from APIM the gateway URL. So we'll get the gateway URL. That's the URL that we need to get to. Notice it's in the overview blade in our APIM app in order for us to, that's like the API endpoint you'd hit, right? So we'll type in URL and we'll paste that in. It really doesn't like the that, so we'll have to right-click paste. Probably was working before for the subscription URL. We just probably had to right-click. So we'll do subscription URL equals double quotations, and we will grab this key here again. So I'm just gonna scroll on down here, grab the primary key. You can use the secondary key, but you really don't need it. So we'll just paste that in here. So there we go. That looks like a key. So we'll hit enter. And now we need to set some headers. So I'm going to do @ curly's OOP APIM subscription key equals $ subscription key. And you're wondering, what is all this stuff here? Well, in PowerShell, I believe this is called a dictionary. In other languages, they might call it a hash. You might think of a JSON object, but it's just a data structure that we need to utilize in order to pass this along. I'm just double checking to make sure I named it all correctly. We'll hit enter, and now we'll use the PowerShell command called invoke web request. I'm hitting tab to autocomplete. It's really nice that it does that. It'll do that even for the flags. So I'll do URL here. We'll do method. I think we don't have to specify the method because it'll already be get, but we'll do it anyway to be verbose. We'll do headers here, and we'll do headers. And we'll hit enter, and we have access denied due to missing subscription key. So here we have a small little problem. So I just got to double check to see what the mistake is. You know what? I was staring at this thinking like there's something wrong here. It's OCP. What OCP stands for, I have no idea. But we'll hit enter and we'll try again. And maybe we'll just print out the headers to make sure it's correct. There's no value in there. So we'll print out subscription key to make sure that is correct. Oh, because I wrote subscription URL. This is what happens when you don't type right. Okay, so not a big deal. Just learning a bit more as we go. And I just want to set that again, and then I'm going to print it out to make sure it's correct. There it is. And we'll invoke this, and we should get back HTML. A 200. So it says, welcome to Azure Container Apps. So that's how you can do a request. Of course, that's with PowerShell. But traditionally, you might use Postman, or you use your API, like an API to do that. But there you go. So yeah, that is how we work with a key, we generate our own subscription key, and work with it to make a request not in the UI. Okay, so I'll see you in the next one. Hey, this is Andrew Brown, and we are still working with APIM, and this time we are going to create a policy, because policies are some of the most powerful things that APIM allows you to do. So what I want you to do is on the left-hand side, in our gateway that we created, we'll go to APIs, we'll go over to My Container, and what we'll do is we'll just click onto any of them, like Get Container. Actually, I want to make a new one. I'm going to call a new one called Mock, because we're going to do a mock request. So we'll do /mock, and if we go there and go ahead and create this. So if we were to use this right now, it shouldn't do anything. If we test this, what will we get back? We get a 404 not found because there's no page there. So what we'll do is we'll go here and we are going to go back to the design and we're going to add our own outbound process. So it doesn't matter what comes in. We're going to always have a mock response come back. And we're going to do that by adding a policy. So go add a policy. You can see there's some basic ones like setting headers and things like that. We're going to go to other policies. We're going to get our policy structure back, and this is for the outbound. I don't know why we clicked through that to get to this, but the idea is that we're going to add a new policy here. So what I'm going to do is type in mock response APIM policy. And I'm just looking for all the ones here. So here's a bunch of policies, and we're just looking for the mock one. It's not a very verbose like very flexible one. You just basically set the code. But it does work. So what we'll do is just paste that on in there. And we'll say we want this to be a 200. And we can say whatever we want to get back. So like if we want a different type, like, I don't know, CSV file content type. It'd be text CSV. It doesn't matter. We can do whatever we want. Application MS Word, right? Like, I'm not sure what would happen, but let's do it for fun. Could have just done JavaScript, but no, let's make it complicated. And so now, if we were to go to this mock request, and we were to test it, and we'd send it, let's see what we get back. Okay, it says 200 mock, and I mean, it doesn't complain about the content type, but let's just do this up in Cloud Shell just to make sure that we know what we're doing. So we were doing that before, so we're going to do it again. Okay. It's good practice. So we'll just test our new endpoint, make sure it works. This drag is sometimes weird, so I clicked it, and then it's just like, it's still dragging. It's very frustrating. Sometimes you have to frickin' open it up like that. So silly. But yeah, what we'll do is we'll just do a bit of PowerShell again and get this working. So I'm just Dell. We'll check in on how to do that. So the first thing is we need the URL. What if we hit up? Oh, we still have our stuff from before. So yeah, you want to set a URL for the gateway. You want to set a subscription key from before. We did that in the last follow along. And then we need the headers. But it's slightly different here because the URL needs to be /mock. And then what we can do is invoke a request. We get back at 200. So no issues there. So there you go. That's all it takes to set a policy. There's obviously more complex policies there, but this is a simple example because you really got to go digging through these here, and it's not really worth it to do that unless you actually doing it for real. But there you go. So what we'll do is clean this up. We're all done with APIM. Look for that there. Delete this. And there you go. So that is APIM. And I'll see you in the next one. Something throughout this course that keeps getting mentioned, at least for the AZ204, is distributed application runtime, or also known as Dapper. And, you know, it's not going to show up on any of the exams, but the idea is that it's good to know what it is. It is a Microsoft thing that they had built. It's distributed application runtime, short for Dapper, provides an API that simplifies microservice connectivity. So Dapper is a portable, event-driven runtime that makes it easy for any developer to build resilient, stateless, and stateful applications that run on the cloud and edge and embrace the diversity of the language and developer frameworks. And it's interesting they say diversity of languages because it doesn't support my favorite language, which is Ruby, yet it supports PHP. Kind of explain that one to me, but Dapper provides basically a bunch of functionality. So the idea is that you are going to write your application code up here, like whatever language you want. And then the idea is that you can communicate via a gRPC or HTTP or API to a bunch of standard services. So like service-to-service invocation, state management, pub sub, resource binding, triggers, actors, observability, secrets, configuration. It allows you to connect to edge infrastructure. Now, basically, these are just basically wrappers, so to speak, for you know, standard functionality that you'd want to have alongside a microservice application. Dapper is not taking off as you would think it is. I don't know anybody that's really like that interested in adopting it because it is like this thing is more in the cloud native space, like Kubernetes, CNCF. And the thing is that unless there's buy-in with that community and that this is truly agnostic, you know, you're going to have a hard time to see adoption unless it meets those things. It just does not. It's very interesting. I think it'd be really cool to build an application on top of Dapper for your microservice applications, but I strongly doubt anyone would be using this because the future of this project is debatable. But it is mentioned throughout this course, so I just wanted to give you a little bit more attention there. We're definitely not going to dig in any code with Dapper, but there you go. Hey, this is Andrew Brown from Exam Pro, and we are taking a look at Azure Event Grid, which is a service that allows you to manage event routing from any source to any destination. So, Event Grid provides a simple and strong customizable event delivery process that allows you to manage at a minimum level which type of events will be received as well as which subscribers will receive those events. So here is an example graphic. You can see Event Grid is kind of sitting in the middle there where events are being captured and being managed by Event Hub, and it's routing to other places. So Event Grid is ideal for event-driven architectures where you can subscribe to Azure resource events and publish them to an event handler or webhook. You can also use custom topics to create custom events that will be published in your Event Grid. and it supports event fan out with 24-hour retry reliability to ensure that events are delivered. It is a low-cost serverless product that supports dynamic scalability. So there you go. Let's talk about event source and handlers. So Azure Event Grid is divided into two categories: event sources, services that emit data, and event handlers, services that receive data. And in between them, that is where Event Grid is. So let's talk about what there is that can emit sources. And this will just give you an idea of how much Event Grid can integrate with Azure services. So we have blob storage, resource groups, subscriptions, Event Hub, Media Service, IoT Hub, Service Bus, Azure Maps, Azure Container Registry, Signal R, Azure App Configuration, Azure Machine Learning, Azure Communication Services, Azure Cache for Redis, Cloud Events, Azure Policy, and custom events. So basically anything you want to get in there. And I'm sure there's more native support for other services, but as you can see, we're limited for space, but it can receive messages from a lot of places. For event handlers, the services that receive data, it could be for serverless code. So think Azure App Functions, things like that. We have workflow and integration. So think Service Bus, Logic Apps, buffering and competing consumers. So Event Hub, Storage Queue, other services and applications. So think hybrid connections like WebSockets or webhooks or even automation. So yeah, there you go. All right, let's take a look at the key concepts for Azure Event Grid. So here we have this fancy diagram. At the top here, we have domains. So these are used to group Event Grid topics that are related to the same application for easier management. Then you have topics. These are the endpoints where events are going to be sent to. There's different types of topics. We have system topics. These are built-in topics provided by Azure Services. This is the most common kind you are going to be using because they're super easy to use. We have custom topics for applications and third-party topics. And for those third-party topics, they emit their own partner events from third-party SaaSes to publish events. So they're similar to system topics. It's just that they're with third parties. Yeah, there's some variation there. We have events. These are the actual event data that occurs within the service, not visualized here, but you get the idea. Publishers, this is the service that published the event. So you cannot see them on this diagram, but the idea is imagine you have a publisher here, and they are the ones where the event sources is coming from, okay? We have event sources. This is where the event took place. Event subscriptions. These are the mechanism that the routes that route the events. Sorry about that there. So over here you can see subscriptions. Subscription expiration. So this is where you set an expiration for the event subscription. You have event handlers, which is over here. You could say consumers if you'd like, is the app or service that receives the events. You have event delivery. This is the delivery of events in batches or in single events. So it just depends on how you want to send those messages. You have batching. So this is sending a group of events in a single request. And there you go. Hey, this is Andy Brown from Exam Pro, and we're going to take a look at Event Grid basics. So let's get to it. So the first thing we're going to want to do is we're going to search up subscriptions, because we're going to need to make sure that in order for us to use Event Grid that we have it turned on. And so we'll go into our subscription and we're going to go under resource providers. There it is. And this is all the stuff that is registered, all the providers that are registered. So what we're doing is just making sure that Event Grid is turned on, because that one's not always turned on by default, and just make sure that it's registered, okay? So you'll know that it's registered because it'll have a green check mark here and it'll say registered. And so once that is done, we can proceed to create a storage account, because we're going to integrate a storage account into our Event Grid. So what we'll do is create a new storage account. And we're going to create a new resource group. I'm going to call this resource group Event Grid Basics. And we're going to name our storage account Event Grid Basics. All right. And yes, you can have hyphens. You can't have anything else. And we'll just make sure we spelled that right. Event grid basics. I can't remember if these are fully qualified domains. If they are, you might have to add some numbers on the end there, but it is what it is. We're doing USC. I mean, it just randomizes every time, but this is where you should probably set it to. We have standard premium. We'll leave it as standard, and everything else seems fine. So we'll go ahead and create, review, and create, and then it's going to allow us to review. We'll go ahead and hit create, and it's going to create the resource group here. We'll just wait for it to finish deploying, and then we'll go into the resource. All right, looks like it is finished deploying. So we're going to go ahead and go to that resource. We're going to go to containers, and we're going to have to create a couple containers. The first one is going to be called basic. We're going to leave it as private. Just make sure it's basic, not basics. And we'll create another container called basic alt. The idea is that we're going to use an event grid in order to move one file from one storage account to another. And that's going to be facilitated by via a logic app, because that's going to be the easiest way to use event grid. So what I want you to do is search for logic apps up here. And we're going to go ahead and add a new logic app. And what we want to do is choose our resource group, and we'll just go event grid basics here. We are going to name this event grid basics. Maybe we'll do LG to indicate that it is a logic app, or LG. Maybe LG is fine, like short for logic. And from here, we have a workflow or a Docker container. We're going to stick with a workflow. Just to knock on wood, we're going to just put in the same region as our storage account. So East US. We have standard consumption. I'd rather do consumption for this. So you pay only as much as you use, because we don't need enterprise level serverless application here. We just need a consumption model. We're going to leave this to disable, so that is totally fine. There's nothing else to do here, so we'll go review plus create. And we'll go ahead and create this logic app. And we just have to wait for this to finish deploying. All right, so that should have been very, very quick, like under 10 seconds there. So we've gone into the resource. I just click go to the resource. And so we have this very fun interface. And so what we need to do is start with a common trigger. There's a few different ways to get to it, but there should be something on the front here. I don't know if they redesigned this recently. So I'm just going to search start with a common trigger. Oh, yeah, it's up here. Okay. I'm being silly. And so what we want to do is, because this is an event grid follow along, we want to click on when an event grid occurs. And so this is the designer where we can make things a lot easier for ourselves. And so we're going to have to first sign in to authenticate. This is my tenant, Exampro Training Inc. So we'll go ahead and get connected there. Just give it a moment. We'll select Andrew Brown, which is totally fine. And now that is connected. So that is great. So once we are signed in, we can click continue, and we're going to go ahead and select our subscription here. And we need to choose a resource here. So I guess in this case, it's going to be event grid. Event grid. Or, could have swore, yeah, I think that's what we want to do. Let me just double check here. Oh, you know what? It's just not, for some reason I'm searching, it's not auto-completing properly. Okay, I just wasn't sure there. And as far as I can remember, this would be probably an event grid topic. And then we need to give this a resource name. So, let me just think about this for a moment, okay? All right, so I think I understand where my confusion was. It was because we click continue, and I didn't see event grid anymore, so I thought we had to configure it when it was already configured, right? So this is where we were. So at this stage, like event grid's already hooked up, so it's ready to be triggered. So this is the step that follows into it, which is where we want to do our storage account. So that's where I was getting confused. So we'll choose our subscription here. It's okay, you know, if you ever get confused, just step back a couple steps and just double check what you're doing. Happens to me all the time. So what we want to do is actually connect storage accounts. So we type in storage accounts here. Great. We'll have that selected, and then we need to select our storage account. So this one's called Event Grid Basics. And then we're going to have to enter in some additional information, event type. So we want to have it happen when we add something to the container, so the basic container. So we'll do blob created. And then from there, we need to actually filter out the information. So we need to add a new parameter, and I think we'll have to do it on the prefix filter. So a filter like whatever. Yeah, so that's probably a good idea, because then we could place it into a particular place. And I believe that there are very specific filters that you can do for this, because if I recall, there's like standardized ones. Yeah, see here, like it's always going to be /blob, services, default, containers, etc. And you'll know that because, you know, if you read the documentation and you have to do that stuff, you'll figure that out. So I'm just going to type it by hand here, blob, services, default, containers, and then we can put our container name, so basic. I believe we have it without the S there. So services, see, I don't trust my writing here, so I'm just going to copy paste it in. Okay, and that looks good to me. So I think that is what it needs to be. So we'll go ahead and hit the next step. And so the idea is anything in that folder, like when something's added to that folder, then follow up with this operation, right? And maybe before we do that, we should probably, you know, observe that this stuff works. That's probably a good idea. So what I'm going to do here is I'm going to make my way back over to our storage account. So we'll just close this tab here. I'm going to open a new tab. And we're going to make our way over to storage accounts. And we'll go to Event Grid Basics. And we will go to containers. And we'll click into our basic container because I want to just see that this is working. And I'm going to need a file to upload. So let me just go grab an image really quick. All right, so I just grabbed an image off the internet, so I just have data here. But before we upload, we probably should save what we have, because if we don't save it, we're not going to be able to observe it. So I went back to Logic App, and we just hit save in the top left corner. So we'll give it a moment to save, and it looks like it's saved now. I'm just going to go back over to here. If we can look at some of the code that gets executed. I'm just trying to remember where it is, because once it executes, we want to see what happened, right? So what I'll do is I'm going to go all the way back over here, and I'm just going to go and drag, or well, actually I'll hit the upload button. So I don't trust that there, and I'll drag it onto here. Nope, I still don't trust it. So what I'm going to do is just click the files, and I'm just going to grab it this way and say open, and we'll do upload. And so that is now uploaded, and so there is somewhere where we can observe where stuff has happened. So I'm just trying to remember where it is. I mean, we could run the trigger, but yeah, we probably should run the trigger, right? Run. I think it's running, so we'll just give it a moment, okay? You know, I was thinking about it. It doesn't make sense. We shouldn't have to run it because it should just happen automatically. I think it's on the overview page. Ah, okay. So if we look here, we can see the run history, and there's also trigger history of when the things are triggered. So we could manually fire it, but it doesn't make sense. So I think this is the run that we just did. If we click into here, yes, this is what it is. So here we can see what has happened. So if we expand it, we can see the inputs, right? So we have a blob created. It might show some information. So here we can see data. Yep, and it's a WebP file. And so it's gotten this far through. And so that's a great way to kind of like debug. So you can, Logic Run App, you can do it each step. But right now we are using Event Grid to do that integration, right? We're just doing it through Logic App because it's a lot easier. So now that we have that, what we should do is go back to our designer, and we're going to have to add the follow-up step. So we have this. Oh, yeah, okay, so that's the first step. Event Grid doesn't show up there, which is weird. But so we have this step here from our storage account. And so the next step, what we want to do is put it into another container. So that will be the tricky part. So I'm just trying to remember what we do. So we'll hit next step. And I think what we need to do is initialize a variable first, because we're going to have to get some way to grab the name of the string. Because if we go back to our run over here, just give it a moment here, and we go into a run again here, we need to extract some data to pass along, because there are some limitations in terms of how JSON gets passed along or data gets passed along. And so what we want is we just want this part of the name. We want to say, take this name as the identifier so that when we're copying stuff over, it will work. And so what we'll have to do is store that into an intermediate variable. So we'll just type in variables here. And I'm just seeing, yeah, so they look like this, because I can remember. They might be in the built-in. Yeah, that looks a lot better. And so we need a variable, and it's an initialized variable, and we're going to name this file name. And this is a string, of course. And now we need to insert the value. So in here, what we need to do is write an expression in order to extract that information out. So what we'll do is go to the expression tab, and over here you can see we have all sorts of expressions that we can use. So I'm going to type in last, parentheses, and then in there we'll do split, parentheses, and then what we're looking for is trigger body. And then we'll do question mark, square braces, single quotations, subject. How did I know how to do that? I looked it up. I looked it up somewhere, and I just don't feel like there's much reason to teach this part, because if you really need to know, you can go here and learn all about it. But a lot of times, like if you need something, you can just say, I need this kind of function. Somebody's already done it, right? Because there's so many common use cases. So I probably search something like, how do I get the name out of the thing, like for the blob, and somebody had that there. But it makes sense to me. So let's hit OK here, and it should turn purple because it is a dynamic expression. If you type it in here, it probably won't work correctly. You have to type it in here and then hit OK, so it shows up like that. But you notice we typed in like trigger body. So if we go back over to our run here, this is the body here. So when they say trigger body, they're talking about here, and then it was just grabbing that subject line there. All right. So that would be the second step, and that gets it into a variable. But the next part is we need to actually get the blob content and then insert it and then create a new blob. So what we'll do is hit next step, and we'll type in blob and see if we can find anything here. And from here, we need to get the get blob content using path version 2. So I'm just going to scroll down here and take a look for it. There it is, based on the path. And we'll go down here, and I guess it would be access key. Oh, because we're setting up a connection for the first time. So enter name for connection. I know what the storage account is, but what is the connection name? I do not remember. Give me 2 seconds, okay? There wasn't much to help me here, because what I remember before was that you click it and you'd authenticate it like the event grid, but it's not doing that. So maybe we just have to name it something. So I don't know, we'll just say Azure storage account. Maybe it just wants a name. Maybe it doesn't really matter. Oh yeah, like there's sign in. That's what I want. So connection name, yeah, so we'll say, storage account, event grid. Okay. Because if we can just single sign on, let's do that. That's super easy. And we'll click that there. Okay, so this is starting to look how I expect it to look. And so we need the storage account name. I don't know why it's not showing me any names here, but that's okay. We'll just go over back to our storage account here, and it's called Event Grid Basics. So we'll type in Event Grid Basics. Event Grid Basics. That's custom value, sure. I mean, that's what its name is. I'm not sure why it's not auto-completing. But here, what we need to do is we need to provide the path. So it's going to be /basic. And so now there's our environment or that variable. So we'll just click that there. So that will make it super, super easy. Now notice that it is showing basic now. So I just clicked here the folder. We typed it in manually, but we could have clicked here and then put the environment variable in, or this initialized variable in here. But I did type that manually, and it still did work correctly. So we are okay here. Infer the content type. Sure, why not? It doesn't matter if they do. So this gets the content. So now this gets the path. And so the next thing is actually to create the blob. You can't like do an easy clone. You have to do it this intermediate step. That's just how it works. And so what we'll need to do is go to our built-in ones here. We'll type in blob again, maybe standard. And this time we want to create a blob. So there it is. Block blob. No, we just want a blob. And so what we'll do is, I guess we have to connect again. I'm surprised it's not showing the name. Yeah, it's just the name. That's fine. So we'll go back over here. I just don't want to type it wrong, so we'll just copy paste it in. Event grid basics. Event grid basics. Enter custom value because it's giving us so much trouble for no particular reason. Make sure there's no space on the end there. There, now it works fine. And in this case, what we want is basic alt. And the blob name can be the file name, which is totally fine. And the blob content will be the file content. And I don't think we need anything else. So what we'll do is go ahead and click off, and we will save. All right, so that's just the way we're going to have to do it. So what we can do is go back to our overview, and we'll go back to our basic folder, and we'll delete data. Say OK. And we'll go upload. We'll select our file again. We'll grab it. We will upload, and then we will make our way back over to our Logic app. Close this tab here so we don't get too mixed up. Refresh the page, and it failed. So it failed for some reason, so something has not been configured correctly. It failed on the initialize variable, so something's wrong there. So unable to process the template language expression in the actions initialize variable. Inputs at line 0, column 0. The template function split is not defined, is not valid. So it's possible I just spelt it wrong. So what we'll do is go back to our event grid. We'll go back to our Logic App Designer here. Initialize variable. We will click it. And we probably just spelt it wrong. Spilt. Spilt. What if we do LIT? Spilt? Split? So if that's wrong, we'll just scroll on down and we'll just take a look. I could have swore that it auto-completed for us. Oh, you know what? It is spelled wrong. It should be S-P-I-L-I-T. Split. All right. And I'm just double checking to see if there's any other problems here. Nope, looks fine to me. So we'll go ahead and say update. We will save it in the top left corner. We'll go back. We'll delete our file here. We'll say OK. And we'll have to select a new file. We'll click open. We'll just double check, make sure that's been saved. It looks like it's been saved. We'll hit upload. We'll go back to our overview page. It's already running super fast, by the way. And we'll click into it. And we'll see if we get any other failure. So there's another failure. That's totally okay. So we'll just expand it. This request is not authorized to perform this operation using the permissions. So it does not like the permissions I gave it. Totally fine. So we will go back to our app designer. We will go to this second step here, even though it did select this properly. So we'll change the connection. I guess we'll add a new one. So we did 80 integrated. Oh, let's do managed identity. You must enable managed identities in the Logic app to use managed identities authentication. You must grant required access to the identity in the target resource. Okay. There is an identity tab, so we can go over there and take a look there quickly. I don't remember it being that hard to do. System assign managed identities restricted to one person resource is tied to lifecycle. You can grant permissions, etc., etc. Can we just turn that on and hit save? Well, it can be granted access resources protected by AZ. Sure, let's give it a go. All right, so it seems like we have to assign some role stuff. So we can try and assign a role. Can we do it at the subscription level? Contributor. Okay. Clearly, there's a few different ways you can authenticate, so hopefully this will be the easiest way to do it. We'll refresh here. Did it assign it? And I don't think it said it. All right, so give me a moment and let me see what I can figure out, okay? You know what, just to make this easier, I think what we should do is just do the access key, because that seems like the easiest way to do it. I was just hoping that we could have, you know, just did a simple sign in here, but it's not a big deal. So we'll hit change connection. We're going to add a new connection. We'll just say storage account, event grid key. And so this is going to want the Azure storage account name. So this one will be the name of the storage account, if we can find it. It's called event grid basics. And then we need the Azure storage account access key. So there's probably a tab called keys. Yep. And we will show the key and we will copy the key. If I don't have to pass along keys, I like to not do that. Please check your account info. Again, storage account access key should be a correct base 64 encoded string. Come on, give me a break here. I am doing what you asked me to do. So we will try this again. This thing just hates me today. Give me a second, okay? You know what? It was really short, so I really don't trust it. So let's just do, I just cleared it out there. I didn't do anything else. What we're going to do is go back here, click the copy, and then right-click and paste. That's so much longer. Okay, that has to be the right key. We'll hit create. And we'll give it a moment. Okay, great. So that's for that one. But this has to have the right connection as well. So what we'll do is just change the connection. You have a few here, eh? And the one we want is the one that's valid. So we'll go to this one down below. As you can see, a few attempts here. And we'll save it. And we'll go back to our overview here. I'm just going to close that tab out. We're going to close this out. We're going to go back into here. We're going to go into our containers. We're going to go into our basic. We're going to go ahead and delete this. We'll say OK. And we will upload a new file. We will choose the new file. We'll choose data. Upload it. We'll go back over here. And I want to see the latest run here. We'll give this a refresh. Is it running? It looks like it's running. It's hard because this one looks like it just failed. And now the messaging is getting really muddy here. What is it doing? So we'll click off here. Sometimes the portal is a bit funny. Is it just triggering over and over again? Did we make an infinite loop? Uh-oh. Okay, I think we have a problem here. What if we go here? Is it basic or it's basic alt? And this one's basic. So what's the problem? We'll refresh. Failed. Why did it fail? Conflict. Another active upload session exists. Please retry after some time. Okay. Well, let's just go take a look here. Go back. it's here, so it's here. So it clearly has worked. Why it's triggering multiple times, I don't know. Don't particularly like that. There we go. I'm gonna just go ahead and delete this one here. And it's just going over and over and over again. So there's something wrong with my workflow. So this looks fine to me. That looks fine to me. Maybe it's triggering, oh, you know what? The parameters out of here. So this is supposed to have a prefix here. So what's happening is that it's triggering on any time a basic one is set up or a basic alt one, and it's just stuck in an infinite loop, which is really, really bad. So we did do this earlier, but for whatever reason, the changes still are not here. So what we'll need to do is set up that prefix. So what we'll do is type in blob services default containers basic, because we really don't want to trigger it on any but that container there. And did it save it? It doesn't look, yeah, I mean, it should be there. So what we'll do is go ahead. Like, why is it not filtering? Oh, I guess it wants to filter based on name. But we gave it its name, so I'm not sure what else we would have to type there. Okay. I'm just going to put dot. It's the prefix filter, so data, I guess. I don't know. Like, it's not letting me save. Okay, there we go. So we'll save that. I just want to stop the infinite loop there for a moment. So we'll go back over to the overview. And we'll just make sure we're not running up our bill here. And I'm just refreshing. I just want to see that's not triggering anymore. So it stopped triggering, which is good. And we'll go back over to here. And we'll look at this prefix filter, because I don't remember having to do this. So a filter like sample, etc., etc. So we'll type it in again, I guess. Blob services default containers basic. It's very odd because, like, we typed it. Oh, you know what I probably did? I typed in the filter parameter here, and we're supposed to add it, then put it in there. So it's just me getting confused by the UI. Silly me. Okay, so what we'll do is go back to the overview, and this time we just want to see trigger once. So we'll go back to basic alt. We'll go ahead and delete this. We'll say okay, and we'll go back to our event grid. We'll go in our event grid, our basic container. We're going to go ahead and delete data here again. And we're going to go upload one more time. It's actually good that we had that problem, because I got to show you why filters are so important when we're dealing with the app logic there, or logic apps. So we'll go ahead and hit upload. We'll go make our way back over here. We're going to give this a refresh. And now we have a new one. And it only happened once. And that's what we wanted to happen. So we'll go back over to here. And we go to basic alt. There it is. So that's a means to which we can use Event Grid to integrate stuff. You can see Logic App is extremely useful for developers building all sorts of tools. But we are all done here. And what we'll do is make our way over to our resource group. And we are going to just go ahead and clean up. So we'll go into Event Grid Basics. And we'll go ahead and delete this resource group. There we go. And it's going to go ahead and delete there. Yeah, and there you go. Hey, this is Andrew Brown from Exam Pro, and we are taking a look at Azure Event Hub. So Event Hub is an event ingestor that can consume millions of events from anywhere and process them in real time or micro batching, thanks to the auto inflate feature, which automatically scales the numbers of throughput to meet your changing needs. So it provides an easy way to connect with your Apache Kafka applications and clients Here is kind of a overview illustration of event hubs. So the idea over here is you have different protocols, so HTTPS, AMQP, Kafka, for your event producers to then enter into Azure Event Hubs. You have partitions within your hubs. You have consumers, and then there is the received events, the event receivers. So, hopefully that gives you a quick overview. But let's go dive a bit deeper. Let us take a look at the pricing for Azure Event Hub, but before we do, I just want to expand on a few initialisms so we know what they stand for. We have capacity unit for CU, processing unit for PU, and throughput unit for TU. So across here we have 4 different pricing plans: basic, standard, premium, dedicated. Lots of Azure services like to have a lot of specialized plans built into their services. But as you can see, as you go right, the more expensive it goes. But there's some key differences. So for Azure Event Hub, if you're on basic, you do not get capturing. Capturing costs a bit more. It costs something at standard. At premium dedicated, it's included. If you want to use Apache Kafka, you're not going to get it in basic. If you want a schema registry, you're not going to get that in basic. If you need extended retention, you do not get it in basic or standard. So hopefully that gives you an idea of the differences of these tiers. Let's take a look at the key concepts. A lot of these we'll cover in future slides, so this one is a bit text heavy, so do not worry. But Azure Event Hub helps you build your big data pipeline to analyze logging, anomalies, users, and device telemetry, where you only pay for what you use. So some of the key concepts here are namespace. So it is an endpoint for receiving and distributing events to the event hubs. We have Event Hub, where your events will be delivered. Event Hub Cluster, which is a dedicated event hub with 99.99% SLA. Event Hub Capture, this allows you to automatically capture and save streaming events. We have Event Hubs for Apache Kafka, so this is compatibility with Apache Kafka's setup. Event Publishers, these are applications or services that publish events to Event Hub. Publisher Policy, this is a unique ID used to identify publishers. Partitions are used to organize the sequence of events in Event Hub. Event Consumers are applications or services that read events from Event Hub. Consumer Group, which are they enable consuming applications to each have a separate view of the event stream. Stream Offset, which holds the position of an event inside a partition. Checkpointing is the process of distinguishing between read and unread events, but let's go look at these all in more detail. Let's talk about scaling, because that's a very important concept in Event Hub. So the idea is that there's this feature called auto inflate, and it's basically just a checkbox here, and will automatically scale up to the maximum TU. So throughput units based on the traffic demand. It's not available for basic pricing, as we saw over there. We also have this option of, if we're in the premium tier, you're going to notice there is no auto inflate because it's already there by default, and the unit is different. It's processing units, so you'll just slide that left and right. That's just kind of to reflect what we saw in the pricing section, okay? Let's talk about an actual event hub. So what we do is go name our hub, and we got a few options here. We have partition count. So partitions are data organization mechanisms that relates to downstream parallelism required in consuming applications. Sounds very fancy, but it's just a way of segmenting your data so that you have faster concurrent reads. You have message retention. So this is the period for which your events will retain. So that means that when they're past that period, they are poof, they are gone. Then you have capture. So capture enables you to automatically deliver the streaming data in Event Hubs to Azure Blob Storage or Azure Data Lake store account of your choice, with the added flexibility of specifying a time or size interval. Setting up capture is really fast. There are no administrative costs to run it. It scales automatically with Event Hubs throughput units. Event Hubs captures is the easiest way to load streaming data into Azure and enables you to focus on data processing rather than on data capture. So just a great way to offload into Azure Blob Storage or Azure Data Lake Store. There you go. Let us take a look at producers, because that is what is going to emit events that we'll get into Event Hub. So on the right-hand example, we have some code, because the idea is that you will have to instrument your producer to send out events. So here you can see we've created a client. We'll have to have a connection string, the event hub name, so we know who we're talking to. You would create a producer, and then here what we're seeing is a batch job. So they create a batch job and they push some data on there, and then they send the batch, and then when they're done, they close the client. If there are any errors, we can get some exception handling. This is a JavaScript example. So a producer, also known as a publisher, emits data to the stream. Publishers can publish events using the following protocol, so HTTPS. So most Azure SDKs use HTTPS, as this would probably use underneath. You have AMQP, which is a very popular queuing protocol. Kafka protocol, so if you're using Kafka or you're already using that protocol, then that's another way to get in here. And we just walked through that example. You can publish events either one at a time or batches, as we see here on the right-hand side. There's a limit of 1 megabyte, regardless of whether it's a single event or a batch. Beyond 1 megabyte, events will be rejected. For automation or for authorization, publishers use either Azure AD with auth to issued JWT tokens or shared access signature SAS, which is something we see a lot in Azure services. Let's just talk about some other things. So HTTPS versus AMQP for publishing events. For AMQP, it requires the establishment of a persistent bidirectional socket in addition to TLS or SSL. AMQP has higher network costs when initializing the session. AMQP has higher performance or frequent publishers and can achieve much lower latencies when used with asynchronous publishing code. HTTPS requires additional TLS overhead for every request, so it's going to be up to you to decide whether you want to use HTTPS or AMQP protocol. For publisher policies, Event Hub enables granular control over event publishers through publisher policies, and these publisher policies are runtime features designed to facilitate large numbers of independent event publishers. With publisher policies, each publisher uses its own unique identifier when publishing events to an event hub using the following mechanisms. And I guess there was supposed to be more there maybe, but I think that's pretty much it, because we don't really need to know much more about publisher policies, to be honest. If there's an opportunity, if we do follow along and there's an opportunity, maybe we will take a detour into that to see if it's worth our time. But as far as I'm aware of, I don't think it's that important. But there we go. Let us take a look at a consumer. So here's an example of consumer code. Very similar, kind of similar to the last one here. So we are creating a consumer client. And so here we need a connection string, container name, where we're going to put this stuff. Looks like we're going to put in Azure Blob Storage. We're going to create that client. And then we have a subscription. So the idea is that it's going to listen for data to consume. Okay, and then over here, we can see that it updates a checkpoint. We'll talk about checkpoints soon enough, but let's just talk about consumers in general. So a consumer, also known as a reader, receives data to process from the stream. All Event Hub consumers connect via the AMQP 1.0 session, and events are delivered through the session as they become available. The client does not need to pull for data availability. So that's that. We'll next talk about consumer groups. Well, let's talk about consumer groups here. This is very text heavy, sorry, but there's not much to show. A consumer group is a view, state, position, or offset of an entire Event Hub. Consumer groups enable multiple consuming applications to each have a separate view of the event stream and to read the stream independently at their own pace with their own offsets. So in a stream processing architecture, each downstream application equates to a consumer group. There's always a default consumer group in Event Hub, and you can create up to the maximum number of consumer groups for the corresponding pricing tier. There can be at most 5 concurrent readers on a partition per consumer group. However, it's recommended there's only one active receiver on a partition per consumer group. Some clients offered by Azure SDK are intelligent consumer agents that automatically manage the details of ensuring that each partition has a single reader and that all partitions of an Event Hub are being read from. This allows your code to focus on processing the events being read from the Event Hub, so it can ignore many of the details of the partition. So there you go. Well, let's talk about offsets for Azure Event Hub. So an offset is the position of an event within a partition. And so here's an example, a very ugly graphic from the documentation, but it makes our point clear. The idea is you have a partition, you have You have an event within the partition. There's all these little lines represent event, and that's where our offset is. So offsets enable a consumer or reader to specify a point in the event stream from which they want to begin reading events. You can specify the offset as a timestamp or as an offset value. Consumers are responsible for storing their own offset values outside of the Event Hub service. Within a partition, each event includes an offset. So there you go. All right, let's talk about checkpointing. There's really not a lot to say about it or to visualize it, but it's kind of part of offsets. So checkpointing is a process by which readers mark or commit their position within a partition event sequence. Checkpointing is the responsibility of the consumer and occurs on a per partition basis with a consumer group. The responsibility means that for each consumer group, each partition reader must keep track of its current position in the event stream and can inform the service when it considers the data stream complete. Hey, this is Andrew Brown from Exam Pro. We're taking a look at schema registry, something that is not uncommon when we're looking at event buses. There's something similar in AWS. And the idea here is that you're able to enforce a particular schema of your data, and this will help avoid things breaking for your consumers and have a standard way of expectation of what something is. So the idea here is Schema Registry provides a centralized repository for schemas. This provides the flexibility for your producer and consumer applications to exchange data without having to manage and share schemas between them and also evolve at different rates. That's the key thing there, evolve at different rates. So here we have our schema group. We have a schema. We'll talk about schema group in a second. And then you have schema versions, and then there's the actual schema itself. So schema groups are under your namespace and can be accessed by all topics, event hubs under that namespace. So here you can see we were just setting some options here. And then here's the schema itself. So here we have a very simple example where we have a type of record and name ordered, and we have a couple of fields. But the idea, again, is schema registry really does help you kind of enforce what you expect data to look like for your producers, for your consumers, and there you go. Hey, this is Andrew Brown from Exam Pro, and we are taking a look at Apache Kafka. So the reason we're talking about it is just because Event Hub has a compatibility mode for it. So Apache Kafka is an open source streaming platform to create high performance data pipelines, streaming analytics, data integrations, and mission critical applications. Kafka was originally developed by LinkedIn and open source in 2011. Kafka was written in Scala and Java, so to use it, you'll need to know how to write Java. And the idea is quite simple. We have producers, we have consumers, we have topics, there's a cluster, there's partitions. Looks similar to Event Hub and other kind of streaming platforms. In Kafka, data is stored in partitions, of course, that span multiple machines because it's for distributed computing. You have producers via the Kafka Producer API. You have consumers via the Consumer API. Messages are organized into topics. Producers will push messages to topics. Consumers will listen on topics. So let's talk about that Kafka compatibility. So Event Hub provides an endpoint compatible with Apache Kafka producers and consumers APIs for version 1 and above. So Event Hub Kafka compatibility is alternative to running your own Apache Kafka cluster. So, you know, we said that they're very similar. So Event Hub calls them namespace, Kafka calls them clusters. So you can kind of see that there's that translation over. But the idea is that when you enable this, it will use all the stuff that Kafka is used to seeing. And then the idea there is that you don't have to run a Kafka cluster. You just run Event Hub. If you've already written code that works with Kafka, that's the idea, is that you can drop in Event Hub as a managed replacement. Now, does Event Hub work exactly like Kafka? I'm not 100% sure. So there could be some feature differences. But in terms of protocols or endpoints, being able to replace Kafka with Event Hub if you need to, that's why they have this functionality here. So there you go. Hey, this is Andrew Brown from Exam Pro, and we are looking at partitioning or partitions for Event Hub. So Event Hub organizes sequences of events sent to an Event Hub into one or more partitions. As new events arrive, they're added to the end of the sequence. So the idea is that you have those partitions, olders on the left, newers on the right. Partitions hold the following data about the event: the body of the event, a user-defined property, bag describing the event, metadata such as its offset and its partition, its number in the stream sequence, service-side timestamps at which it was accepted. Partitioning allows for multiple parallel logs to be used for the same event hub, and therefore multiplying the available raw input, output, throughput capacity. You can use a partition key to map incoming event data into specific partitions for the purpose of data organization, and the partition key is a sender supplied value passed into an event hub. So there you go. Hey, it's Andrew Brown from Exam Pro. We're taking a look at event retention for Event Hub. So published events are removed from an Event Hub based on a configurable time-based retention policy. And the default value and shortest possible retention period is 1 day. So that's 24 hours. For Event Hub's standard, the maximum retention is 7 days. And we saw that in the pricing page where retention can be different based on those things. So for premium and dedicated, the maximum retention is 90 days. If you change the retention period, it applies to all messages, including messages that are already in Event Hub. You cannot explicitly delete events. The reason for Event Hub's limit on data retention based on time is to prevent large volumes of historical customer data getting trapped in a deep store that's only indexed by timestamp and only allows for sequential access, which doesn't sound too good. If you need to archive events beyond the allowed retention period, you can automatically have them stored in Azure Storage or Data Lake by turning on Event Hub's capture feature, which we talked about earlier. If you need to search or analyze such deep archives, you can easily import them into Azure Synapse or other similar stores and analytics platforms. So there you go. Hey, this is Andrew Brown from Exam Pro, and this fall long we are going to learn all about Azure Event Hub. So what I want you to do is go to the top here and type in Event Hub, and we are going to create ourselves a new Event Hub namespace. So we'll go here and hit create, and we'll create a new resource group as we always do and call it My Event Hub. And then for the namespace name, we'll say My Event Hub. If it doesn't let you do that, you'll have to put some numbers on the end. I'm just putting some numbers here because often these are taken up. Doesn't matter what location is, just choose whichever one. We're going with basic because there's not a huge difference between the pricing terms in terms of feature sets that we want to use today. So we'll go ahead and create this namespace. So we'll give it a moment and we'll go ahead and hit create. And then we'll just wait for this namespace to provision. All right, so after waiting about a couple of minutes there, our namespace is deployed. We're going to go ahead and create ourselves an event hub. I'm going to call this one My Hub. We'll go ahead and hit review and create. And we'll create, and these create very, very quickly, so we're not gonna have to wait too long. We need to set some shared access policies here, so I'm gonna go into the hub here. We're gonna hit manage. I'm gonna call this My SAS, SAS, shared access policy. And there we will now have the ability to have a primary key and connection key so we can actually connect to it. So what we're gonna do is go to GitHub, and I want to create a new repository. And we'll go ahead here and we'll go down below, go to Exam Pro, we'll say My Event Hub. It's already taken because I've done this before. So for mine, I'm gonna call it new. And we'll go down to private. We're gonna use Node.js, so we'll just type in Node.js so that it ignores the Node modules. You're gonna wanna have Gitpod or a Visual Studio Code installed on your computer. The easiest way is honestly Gitpod because these environments are temporary and it's free to utilize it. So if you can, go get the Chrome extension, or if you don't want to install the Chrome extension, all you got to do is attach this to the end of the repo to launch a GitHub or Gitpod environment. So give that a moment to launch. And there we go. So I do have some code for this. So I'm just looking for it off screen here. And we're going to need to have a couple files here. We're going to need a new file called send.js. And we're going to need a new file here called receive.js. I'm not typing the full word receive because I'm always really bad at spelling it, so I'm just trying to save myself some trouble. And we're also going to have to initialize a new package.json file, so there we go. And we're going to have to get a couple things installed. Yeah, so we'll need npm install Azure Event Hubs, Azure Storage Blob, Azure Event Hubs checkpoint, store blob, save dev. And to make our lives a bit easier, it seems like I typed something wrong here. I'll just hit up. I forgot the / here. And so we'll just go Event Hub, Azure JavaScript. Because I believe, yeah, I kind of use this one, but I modified it to make it a little bit easier. I think this is the one I was doing. No, I don't think so. Tutorial. Might be this one. Yeah, it looks like this. So this is just the JavaScript there. So for send, we will grab this code here. We're not going to do exactly the way they do it, but pretty close. And then there is a receive code. So we'll go down below and we'll grab this. As you can see, there's a lot going on here. That will be our receive. A couple things we need to properly set. So these will be all environment variables. So what we'll do is go to the top here and we'll just do constant process requires process. That's going to allow us to import our environment variables. So we'll just say copy. Let's just save that. We'll paste that in there as well. And then this is where we need to replace all our environment variables. As you can see, I always have things pinging up on me here, so I'll just close my teams out. And I'm just lining these to make this a little bit faster. So default will be what we'll keep here. This will be our storage connection string. Say process, env, storage connection string. Then this one will be process env container name. Then we need process env event hub name. And up here we'll have process env event hub connection string. And then we'll go over to our send here. We'll do something very similar. So process env event hub connection string. And then we'll have process env event hub name. So we need to set all of these. I'm just going to copy this for a moment here. I'm going to make a new file. File, new file. Sure, it doesn't really matter. We're just using this as a quick scratch pad. And so what I want to do here is just delete out this part. And we're going to do export on the end here. We'll take out this one here. And the idea is that we'll just set them all here, and then we will make our lives a little bit easier when we have to set these. So we do have the connection string because we saw it over here. So we'll grab the primary one. Doesn't matter which one, primary, secondary. And that is for the event hub. We called the event hub was called my hub, I believe. We'll just double check what the hub was called. Yeah, it's called my hub up there. We'll need a storage account. So what I'm going to do, wish this thing would get out of here, get out of here. I'm not trying to save a frickin' file. There we go. Hit escape a bunch of times. And we'll go back here and we'll create ourselves a new storage account. I'm going to actually make this in a new tab so we can see what we're doing. So we'll go over to storage accounts. And we'll create ourselves a new storage account. We'll create this storage account in the same namespace. So we'll go down to my event hub. We'll just say my, we'll just say my event hub 8888. Again, you might have to change it based on your standards, but or like what is available to you. We'll go ahead and go review, create. And for the container name, we'll probably just call it container. Maybe container 1. We just have to wait for this to grab that connection string. So this usually doesn't take too long, just a couple seconds. Okay, so there we are. We'll go over to access keys, and we'll grab the connection string from here. I believe this one should work. Let me just double check. Yeah, I think this will work. So what we'll do is go back over here. If it doesn't, we'll find out pretty soon, and we'll just generate out a shared policy. We'll go ahead and paste that on in here. And just double checking that this is the correct one. This looks identical to that one. That can't be correct. So we'll go back here. This is the storage account. So we'll go, oh, I have to actually hit the copy button. That's what I didn't do. We'll go ahead and paste that in. And so theoretically this should work. So we'll go ahead and copy these. We'll drag our terminal up a bit. We'll paste these in here. And what I'll do is just double check that they're here. So we'll say env grep event hub. So those are both set. And then we'll do storage. That one is set. And we'll do container. That one is set. So these are all in good shape. For our storage account, we still have to create the container. So go here and create a new container. Say container 1. We'll go ahead and create that. We'll make our way back over here. And then instead of just having export, we'll do gp env. This is just in case we have to restart the environment for any reason so that these environment variables get exported twice. So we'll paste that in there. I believe those are all set. Go ahead and hit enter on the last one there. And let's see if our code works. So we'll do a send. Actually, we have to set up 2 scripts here so that we can actually call them. So that one called here is called send. This will be node send.js. And we'll have receive, so rec. Just because I always spell receive wrong and I just don't want to have to type it 1,000 times, we'll have that there. So now what we'll do is do npm run send. See if that works. It says a batch of 3 events have been sent. We'll go and confirm that over an event hub if it worked. If we go to the overview, it should show us some messages were received. Sometimes there's a bit of a delay. So we'll just give it a teeny tiny amount of time. We'll hit refresh here because we know we sent them. But while we're waiting for those to kind of propagate, what we'll go back here is just kind of look at the code because we didn't really look at it. So the way it works is you are defining a client and it will be the producer client. And then down below, so we say, okay, a producer is someone that produces events. It's very common in a messaging system to have a producer and a consumer. We're going to create a batch job and we're going to add them all to the batch job. Then we're going to send them all at once and it's going to close and it'll complete. And if there are any errors, it will alert us about it. So we'll go back over here and we'll do a refresh. So I want to see messages. Messages would normally show up here. So since I don't trust it, I'm just going to run it again. I mean, clearly worked because there was no errors. And we'll go back over here and not here, but we'll go back here and we'll refresh. And I'm just waiting to see something here. Processing data, this is like something that's really powerful with Event Hub here. So still don't see the messages. Just give me a second to debug this. I've done this lab like 4 times, so it should work, but you know, sometimes there's trouble. So just a moment. All right, so I literally did nothing and now it's actually showing up in the messaging queue. So, you know, or the hub, the funnel. So that's just something you have to consider is that sometimes you just have to be a little bit patient. Let's see if we can go receive those messages now by running the other scripts. So what I'm going to do here is do npm run receive, and it should receive the messages as long as something isn't typed incorrectly. So we'll go back over here. We've seemed to introduce a little mistake, so I'll go ahead and save that. We'll hit up, and it should receive the events. So it should print the 3 out. So there we go. And so we are streaming this, or the consumer is technically storage accounts. But if we go to the storage account, there's nothing really intelligible in terms of what's in here. So like there are stuff in here, checkpoints. I guess it's saved to checkpoint. I personally don't know what I'm looking at, so I'm not exactly sure what the point of doing that. I guess it's just saying the checkpoint is like the last point it wrote. But if we just take a look at the code here quickly, you can see that it's called consumer, so we can hit a consumer client. There's a blob checkpoint store. Then we have the consumer client. We are subscribing, so it's saying, hey, are there any events? Let's consume them. If there are no events, throw a console log, so tell us about it. Iterate through them, then update the checkpoint. So move it to the next point. Just say, hey, this is where it is now. And that's pretty much all I wanted you to do. We can go ahead and save this code. So we'll say Event Hub code. Doesn't matter what you name it there. We'll sync the changes and we'll go ahead and clean up. So we'll go back to our resource groups. We'll go to Event Hub and we will then go and delete this resource group. And we'll go here and there you go. Hey, this is Andrew Brown from Exam Pro, and we are taking a look at Azure Notification Hub. So the goal of this service is to send notifications to mobile apps in order to increase the app engagement and usage. You can use tags to filter which apps or users that will receive notifications, and those apps can be registered in Azure Notification Hub in two different ways. The first way is installation model. So that's where the app sends an installation request to Azure Notification Hub, including all the information needed for the installation to be completed. This model is easier to set up and maintain. And then from there, we have the registration model. So this app sends an Azure Notification Hub registration request with the PNS handlers and tags, and Azure Notification Hub responds with the registration ID. It's great for native or generic templates that can be used in order to define the message. So, Azure Notification Hub, in order for us to actually show off how to use this thing, we'd actually have to set up a mobile app, and it's not easy to do. So this is something where we do not have a follow along for. I don't think it's a big deal because I really didn't see it on the exam, but it is part of the material, so we definitely should know what it does. So we'll just continue on here and learn a little bit more about Azure Notification Hub, okay? All right, let's talk about the supported platforms that Azure Notification Hub supports. This gives you an idea of how it can be used with different mobile frameworks because, we all don't use iPhones. There's Androids and other things like that. So for Android, we're going to see support through Firebase Cloud Messaging. If you do not know what Firebase is, it's Google's cloud platform as a service. It's a way of building out applications similar to AWS Amplify or Supabase. But the component for messaging is through that SDK for cloud messaging. This used to be called Google Cloud Messaging. So if you go through the documentation, you might see this. This does not exist anymore. You have to use Firebase Cloud Messaging, okay? For iOS, we have the Apple Push Notification Service, APNS. And so through that, it's going to be notification hubs for iOS 13. And the way that works is through Objective-C SDK. I don't think there's support for Swift, or at least I could not find it, but this is only important if you are a native mobile application developer. But basically the idea is the Objective-C SDK is how you would interact with it. There's also a notification hub for Xamarin. I always say Xamarin wrong for iOS applications. Xamarin is, I'm assuming the X is pronounced like an S. I don't know why, I just assume. But that is a technology, a framework built by Microsoft that allows you to build out native applications for a variety of things like iOS and Android and things like that, and Windows Phone, of course. For Windows Phone, the way we're going to communicate is through the Microsoft Push Notification Service, so MPNS. For Windows, because I suppose you can build a Windows application, not just a Windows Phone. This is through the Universal Windows Platform, so UWP app. And from there, that is the Windows Push Notification Service, so WNS. So, this is just to give you an idea of the broad stuff and get you exposure to a lot of these terms. Again, I don't think that's going to show up in the exam, but good to know for Azure Notification Hub, okay? All right, let's take a look at how message flow works for Azure Notification Hub. So notice this tower here. So this is the platform notification service by your provider. So if you're using Apple, they have their own, Microsoft has their own, et cetera, et cetera. And the idea is that Notification Hub is connected to that, and that's how notification gets pushed out. So Notification Hub is just pushing to this tower, and then this tower pushes out to tablets that are subscribed, okay? But let's go through the flow here because there's some interesting things about handles we need to know. So the idea is that your app says, hey, I want to subscribe to push notifications. So it sends a request to your platform notification service, and it's going to get back a handle. That handle is going to vary. So if you're using Windows notification service, you get back a URL, a URI. And for Apple's, you're going to get back a token. So then you have to store that token into your application. So it comes back to your phone, your tablet, whatever. And then it goes, okay, to the back end and then stores that token here. And then the idea is that you can then use that token that whenever your app wants to notify all devices that are registered for push notifications, it's going to then push it out. With the handle, it's going to go to the platform notification service, and then that's going to roll it out. And then all your apps are going to receive that information. So hopefully that makes it pretty clear how that works, okay? All right, let's take a look at some key concepts or components that are in Azure Notification Hub to just kind of cement what we learned about the message flow and just the service in general. So Azure Notification has these key concepts. So we have routing. This is the process of selecting which registrations will receive the push notifications. We have the idea of broadcast. All registrations will receive the push notification. A tag, registrations that contain the specific tag will receive that push notification. A great way to narrow down who you want to notify. There are tag expressions, so registrations that match the tag expression will receive a push notification. So that is an even further way of narrowing down who we want to receive a push notification. There's the Notification Hub namespace, so you have to create a group of one or more notification hubs in order to send stuff out. Tags are used to label applications so that they can be routed more efficiently, which is what we were talking about here just a moment ago about tag and tag expressions. You have templates. These define the format on how the client will receive the push notification, and it's platform specific. Okay. Each platform it says platform independent. So platform specific, I think, is probably a better word there. Each platform has its own platform notification service, which is in charge of push notifications. So the idea is that push notification hub or Azure Notification Hub is just basically an adapter to all these a variety of services that are offered by these other telecom or notification companies, okay? Hey, this is Andrew Brown from Exam Pro, and we are taking a look at queuing. So both Azure Storage Queue and Azure Service Bus have overlapping responsibilities because they're both messaging or queuing as a service. And so just before we jump into both of these services, I wanted to distinguish the differences between these so you can kind of identify the use case for them. So we have Azure Storage Queue. This is a simple message queuing service to store large numbers of messages. Then you have Azure Service Bus. This is for broader messaging service that supports queuing, pub sub, and more advanced integration patterns. So let's talk about the storage queue side of it. So this can handle millions of messages. There's no guarantee of the order of messages. There's at least once delivery, which is really nice. 500 terabytes max queue size, 64 kilobyte message, kilobyte message size, and 48 kilobytes if you're doing base 64 encoding. So that's the size it can be after the encoding. Unlimited queues, unlimited concurrent clients, least-based access mode. So we got 30 seconds to 7 days set for the entire queue. And then on the right-hand side, looking at Azure Service Bus, it can offer first in, first out, which is very useful. Guarantees the order of messaging being consumed. That's what a first in, first out means. At least once or at most once delivery. We have 1 gigabyte to 80 gigabytes of max queue size, 256 kilobytes to 1 megabyte, so a lot larger than Azure Storage Queue. We only have a maximum of 10,000 max queues, but that is a lot of queues. I don't know what you're doing with more than 10,000. 5,000 concurrent clients, lock-based access mode, and that is with 60 seconds, can change settings per message, and it has dead letter support, which is very useful. State managed support, message group support, deduping support, purging queue support, and transaction supported. So, the thing is that it looks like Service Bus wins in all categories, but again, remember that Storage Queue is simple, and because it's simple by design, it can handle millions of messages. And if you don't care about first in, first out, it makes sense. So you really have to decide in your use case. There probably is a pricing difference, which I think that we do cover in this course, but hopefully you get an idea that these two services do the same thing, but in different ways, okay? Hey, this is Andrew Brown from Exam Pro, and we are taking a look at Azure Queue Storage, which is a simple message queue that allows you to exchange cloud messages. It's used for application integration between services, and it allows that via an authenticated HTTPS endpoint or protocol, and it can accept messages of 64 kilobytes in size. So the queue storage is a service or a product underneath the Azure storage account. So you first have to create a storage account. And then from there, you create your queue, but you'll be using the same access keys and connection strings like the rest of the other storage account resources. There are 3 ways of handling messages for Azure Storage, Azure Queue Storage. The first is peek, and as it says, it will retrieve or look at a message in the queue without removing or locking it. You have delete, so that will delete a message that is being processed, and receive, so that is a message in the front of the queue, but it gets locked temporarily while it is being used. Okay, and just to kind of give you a visual of how simple it is to use this queue, you can, in the UI, in the Azure portal, you can open it up, write a message, set an expiry, and just say, okay. But the way you're generally going to be using it is not through the UI, because these are for application integration. That means you're going to be writing either SDK code or utilizing the CLI. And I believe that Azure Queue Storage is one of the ones where you can actually use CLI. We do cover that as the difference between the other queuing service that you can use in Azure. But here's an example of the Azure SDK. It's a Python example. So just getting my pen tool out here. It is a bit brief, but the idea is that we have our queue client. We have our connection string URL, which we're getting from our storage account. We're putting the name of the queue, and then we just send a message. So it's that simple, and that is a Python example. Let's just talk about some of the components within a queue. There's not a lot here, so it's not too complicated, but the idea is you have a queue. This can be accessed by using a URL format of the following. So you'll have your storage account here, queue core windows.net, and then the queue name. Would this show up in the exam? Probably not, but it's generally good to know just in case, because Azure exams are very tricky. And then we have also this URL here as an example. So I think it's reflecting the example on the right-hand side here. So the idea here is that we have my account. So this is my account. And then we have images to download. So images to download would be one particular queue. Okay, so just to kind of hit home that URL there. We have a storage account, so this is required in order for us to make a queue. As we mentioned, you have the queue itself. This contains a set of messages. The queue names must be in all lowercase. So that's just one of those interesting use cases or edge cases. Messages can be up to 64 kilobytes in format, so it's very small. So this is where you might want to use the other queuing service within Azure, which I can't remember, but we do cover it when we get to that section. And there is some versioning that's a bit different. So if you're using before 2017, the TTL on it is a max of 7 days. If you're using after 2017, it can be any positive number or -1, indicating that they don't expire. And it doesn't say, I guess it can be whatever number you want to be. I don't know what the maximum is, but I mean, what's important to know is that the old one gives you 7 days. So you're going to be wanting to use the latest version to have the most flexibility. The default time to live is 7 days if the parameter is not specified, which is totally fine. Let's take a look at some of the CLI commands because, when I'm making this course, it's specifically for the AZ204, which means developer. So you're getting lots of hands-on stuff. So you should really know these CLI commands. We do cover them in the follow along here. But the idea is we have the AZ storage, because we're using storage count, message, action. So that's going to be automatically for the queue. So we have clear, so delete all messages from the specified queue. Delete, so delete a specific message. Get, so retrieve one or more messages from the front of the queue. Peek, so retrieve one or more messages from the front of the queue, but do not remove them, do not change their visibility, do not lock them. Put, so add new messages to the back of the message queue. Update, updates the visibility timeout of a message. So these systems are very, very, very simple, but they're also highly scalable, which is really great. Yeah, there you go. Hey, this is Andrew Brown from Exam Pro, and in this follow along, we're going to learn all about storage queues. So what I want you to do is log into the Azure portal, and at the top here, type in queue. And so that's going to show you, it's going to bring you to storage accounts because it is not a separate service. It's underneath storage accounts. So what we'll do here is we'll create ourselves a new storage account. So we'll hit new or create there. Give it a moment to load, and we're going to create ourselves a new namespace. I'm going to call this one AZ204, AZ204 Azure Storage account. Actually, we'll just say storage account queuing, or queue. We'll say OK. there. This will be called AZ204 storage account queue. And it doesn't like the hyphens, maybe. There we go. And we'll let it launch in whatever region it wants to. Here it's going to be East US. For performance, we'll stick with standard. We'll stick with redundancy of geo-redundant storage. It's not going to matter for those options for using the queue. We'll go to advanced to see if there's anything interesting there. Nothing in particular. I was just checking if there's anything for the queue. And so we'll go ahead and hit review and create. We'll scroll on down and hit create, and we'll give that a moment to create. So in order to utilize the queue, there isn't much in the UI that we can do in the portal. And so we are going to need to utilize the Azure CLI. So, there's a few ways we can go about this. We could launch up Visual Studio Code, but since it's all CLI driven, what I'm going to do is go ahead and actually open up Cloud Shell, and that's the way we're going to interact with it. Now, if this is your first time spinning up Cloud Shell, it might ask you to create a storage account, and so just let it do that. And now this resource is complete. We'll click into here. And on the left-hand side, we're going to make our way over to queues. And I'm going to create a new queue. I'm going to call that my queue, and we'll hit OK. So for this, there wasn't really a follow along in the Microsoft documents, so I just kind of made my own. And so for that information, I have a repository, and you'll find this throughout the course, which is called, I'm just looking it up here on the side here, the Developer Associate. So some of these are reworkings of Microsoft ones, or they're my own creations. So this one in particular, which is Azure Storage Queue, is a bit more unique. And so the things that we're going to need to do is you're going to need to have a connection string in order for us via the CLI to connect it, because all the commands we're using, like put, peek, get, all these things are going to rely on it. In terms of what we want to run, I'm going to type in Azure queue message CLI, because this is mostly what you'll want to know how to use, is how to interact with messages. There's a bunch of different CLI commands for Azure Storage, like working with a queue and stuff like that, but I'd rather just work with messages because that's the only part that we can't do here, and that's where we need to understand the difference between peek, get, put, and things like that. So the first thing we'll do is get a connection string URL, and I believe that is for the queue, so we'll go into queue here, click into the queue, because sometimes it is the access key that is at the storage account level, and sometimes, like if you go here, sometimes it is, so there's keys here, sometimes it's the queue. So I think it is the queue key that we want, and if it isn't, we'll find out very shortly here if we've made a mistake. So what we'll do is we'll go back to our resources here, we'll click into the queue, and in the queue again, and we'll look at access policies. And so we can add a policy here. Nope, you know what it was? It absolutely is the storage account that we need. So we go down here and we type in access, and we have access keys. So here it is. And between different Azure services, sometimes this is called access keys, and sometimes it's called something else. We're going to discover that as we do other follow-alongs. Just understand that this is not always consistent based on the UI, but what we need is a connection string. So we'll click show up here, and what we'll do is grab this string. And so what I want to do is type in export queue connection string equals, and then double quotations. Very important that you put those double quotations, because if you don't, this equals will terminate here, and it'll only think this is part that is set here. So I'm going to hit enter, and so that's going to set us an environment variable for this. So if I did env-grep and put in this is how we can check if it was set correctly. Okay, if you've never done this, if you type in env, that shows all of your environment variables. And so all grep is doing is saying, find the one that's called this. I could even do it like this, right, partially, and it would return it here. So that's one thing. The next thing is we need the queue name. So we named it, I believe, my queue. So if we go back to our storage accounts here, and let's just click back onto here. Such a pain sometimes clicking around here. We'll go to queues, and we named it my queue. So I'm going to set export queue name equals, and we don't need double quotations here, but I'm going to do it anyway, my queue. We'll make sure that is set correctly. So we'll type in grep queue name, and there it is. So some of the first commands we will want to use is things like put, because put will allow us to enter stuff in. So we said that there are these messages here. So we'll go to the put command here. You can see there's a lot of options. When you want to know what you need to put in, all I do is just copy the base thing and paste it in. And then it'll just tell us. So we'll just give it a moment here. And so it complains. It says we need the queue name, we need the content, and I already know that we need the connection string URL, even though it's not saying it there, because it might say, hey, you need, actually down here it says connection string, account name, things like that. So just to make this easier, I'm going to go open editor here, and this is a terrible, terrible editor, but when we're working with like just some text here, it makes our lives a little bit easier. So what I want to do is just type it up here before we paste it in. And of course, this is all in the repository, but I'm just doing it by hand, and I recommend that you do it by hand like I'm doing, so that you have a better chance of committing to memory. So we type in Azure storage message put. I'm going to do a backslash so we can do multi-line here. We're going to do connection string equals, and we set that as an environment variable called queue connection string. When we do this $, that allows us to access the environment variable that we set earlier. And we do that is because we have to run a series of commands, and it was just a lot easier to pass this in consistently as opposed to passing in that raw string every time. So we need to provide the queue name. So this would be queue underscore name. And then we need to provide it content. So we'll say hyphen hyphen content equals, and I'm going to say hello world. And so we will copy the contents there. I'm going to just type clear here so I can see what I'm doing. We'll go ahead and paste that on in there. We'll hit enter. And yeah, so it is now in the queue. Now, one thing that I was not able to figure out was how do you observe how many questions are in the queue? I'm not exactly sure. So if we go into here, I'm not sure if we get any statistics. Oh, well, we have a message right here. So we can see there is one in the queue, but what I was trying to say is that when I was using the CLI, I was trying to find a CLI command to find that, and I just never did, but it's nice to see that we can see it visible here in the actual console here. I want to have more than one message here because I want to show you how visibility works. And so what we'll do is just paste Command V. There is no, if you notice right click, there's no paste here, which is kind of weird. And so I'm going to do here hello Mars as our second one. And we'll copy this here, copy it, paste it on below, hit enter. And so now we have two queued up. If we refresh, we can see we have two messages in our queue. We can even add a message here if we wanted to. So we could say, hello, Jupiter. And hit, maybe I have to scroll down here. Oh, no, it vanished. I got to do it again. Maybe bring it down all the way down here, add message. There we go. Hello, Jupiter. We'll say, okay. And notice that we have some options there where we can set the expires in X amount of time or whether it never expires and things like that. But anyway, what we'll do is now we should probably attempt to peek or get. So what we'll do is go back to the top here. So I think they list them out. So we have get. So retrieves one or more message from the front of the queue. And then you have peek. So retrieves one or more message from the front of the queue, but does not alter the visibility of the message. So when we say visibility, the idea is that when somebody accesses a message, they're now looking at it, right? And so nobody else can read it. And the reason why that happens is to avoid two people doing the same job by accident. But if we use peek, that means that it doesn't become invisible. It will just remain the same. So let's do peek first. And so what we'll do is we'll just copy this here and paste this in. Oh, we have to do Control V there. And we'll just get rid of the content line because we don't need to pass content. We still need the queue. We still need the connection string. And I'm going to change this to peek. And so what peek should do is it should return us what's on the front of the queue. So this is the top up here. We'll go ahead and copy it. Then we'll right click and paste down below. We'll hit enter. And so we get hello world. If we were to hit up and run it again, we would still get hello world because it has not been marked as invisible, right? It's still visible. So now let's go ahead and change this to get. Oh, we got to paste. Control V. So we do get here. And copy, Control C or Command C, depending on what you're using. And we'll paste that in there and hit Enter. And so now it says Hello World, as it did before. Both times we ran Hello World, it was always returning the same one. Okay, notice it says DQ count is 1, so we'll go here and refresh. And notice that Hello World is not appearing now. Right? So it's because it's not visible. It's still there, it's just not visible, right? And so the next thing we can do is if we hit enter again, now it types in Hello Mars. Okay. And the next thing we can do here is clear the queue if we want. So that's probably something that we should do. So if we were to go here and copy this, type in clear. And hit enter. That should clear the entire queue. So hopefully that gives you an idea of how the queuing system works. Of course, you can use the SDK. So like if we were to type in Azure Storage Queue documentation, and we were to go to tutorials, there's probably, or samples, there's probably like examples. I always go to JavaScript because it's the easiest one to read. And if we go down to messages here, send a message. Not really great that they don't have this inline, but the way it works is you probably import the library at the top. So you'd install with npm install Azure Storage Queue. You have the client, the credentials, and then down below here, you're creating your message. I guess you have to create the client queue first up here. And then you pass along your message sent, and then it says whether it's been sent or not. Here you can see that they're using peak, right? Very similar. Receive message, all very similar here. So hopefully that gives you kind of an idea. I think like for get, or sorry, like notice like it's called receive message as opposed to get. So in the CLI, we did get, but this is really receive, right? So just so that translates over. These queues are extremely simple, but they're designed to be extremely simple. When we look at Service Bus, you'll see that it's a lot more complex. But one of the key differences, at least pragmatically with Service Bus and Storage Queue, is that Service Bus allows you to use the CLI to insert messages, where when we do Service Bus, we have to write code using the SDK, and we will do that. But yeah, that's all there is really to this one that I want to show you. What we'll do is make our way over to our resource groups. I'm going to just close off our shell here. We're going to look for the one we just created here. So this is Azure Storage Account Queue. We'll go ahead and delete that. Delete. And it should all be good. Of course, always double check. 5 minutes from now, make sure that stuff is deleted, because Azure is notorious for sometimes not deleting things, or you think that things are being deleted, but this won't show up immediately. It'll take some time to propagate through their servers, but there you go. Hey, this is Andrew Brown from Exam Pro, and we're looking at Azure Service Bus. So Azure Service Bus is a fully managed enterprise message broker that allows you to publish and subscribe to topics and queue messages. It can scale with your applications with asynchronous messages and built-in integration with Azure services. So here is an example of Service Bus. And so, the way it works is you have producers, you have consumers. And so producers are sending messages or events into an event bus. The event bus is designed to broker that information, so pass it along to the ones that are subscribed. So these applications which are consuming are subscribed to specific messages, and they pull data to get them into those target end applications. Some things we need to know is you can handle single or batch messaging, load balancing messages, topic subscriptions, manage sessions, and transactions with guarantees that it compiles with industry standards and protocols like the Advanced Message Queuing Protocol, so AMQP, Java Message Services, so JMS, and other protocols there. So they're just saying, like, yeah, if you're already using very particular protocols, you can integrate with those. Let's talk about key concepts for Service Bus. So the idea is that you have a namespace which works like a server, with end queues and topics. You have queues which contain the messages. You have senders who send the messages, receivers who receive the messages, topic, which is a queue with multiple receivers that work like a queue. A subscription is a receiver in a topic. A batch is a group of messages. A safe batch validates if each message can be included in the batch. Sessions allow you to use first in, first out, and group your messages in a queue. Peak returns a message to the queue without removing it. Dead letter queue, a queue for messages that were unable to be delivered through the normal queue. Peak and lock, so this retrieves a message from the queue without removing it and locks it so other receivers cannot receive it. Receive and delete, so receives and deletes messages from the queue. Auto delete on idle, so sets a time span to delete the queue if not used. Duplicate deletion detection history, so checks if the message was not sent earlier before sending it a message. So there's a lot of stuff here, but don't worry, we're going to kind of cover it, the most important stuff here in the upcoming slides and in the follow along, okay? Let us talk about namespaces for Azure Service Bus. So simply put, namespace is a container for all messaging components, so queues and topics. But there's a few options here. I don't have a visual, but there's some text we have to go through here to understand some of the things that namespaces do. So a single namespace can contain multiple queues and topics, and namespaces are often used as application containers. So a service bus namespace is a capacity slice of a large cluster made up of a dozen of all active virtual machines that you control. It may optionally span 3 AZs or availability zones in Azure. You get all of the benefits of running the message broker at massive scale in terms of availability and robustness. A service bus is serverless messaging, so you don't need to worry about the underlying complexity, which is kind of interesting because they're mentioning about spanning across availability zones and virtual machines, but it's just a component that you don't have to worry about the management of it, but you do need to know a little bit about how it works underneath. But there you go. Hey, this is Andrew Brown from Exam Pro, and we are taking a look at queues for Azure Service Bus. So there's 2 types of messaging systems in Azure Service Bus. Why they didn't make these 2 separate services, I have no idea, but one is for messaging and one is for PubSub, and the one that is for messaging is called queues. So queues are used to send and receive messages. Messages are stored in queues until the receiving application is ready to accept and process them. Messages in queues are ordered and timestamped on arrival. Once accepted by the broker, the message is always held durably in triple redundant storage across multiple AZs if its namespace is zone enabled. So if you don't enable zone enabled at the namespace level, you're not going to get that kind of durability or redundancy. Service Bus never leaves messages in memory or volatile storage after they've been reported to the client is accepted. And messages are delivered in pull mode, only delivering messages when requested. That's the key difference between a queue and PubSub. Queue, the receiver, the application has to pull, say, hey, are there any messages in the queue? And that's how they get them. In a PubSub model, they just get it sent to them like a subscription, like a newsletter subscription to your door. Let's take a look at the queue configuration itself. So you can see we can set the max delivery count, things like that, the queue size. Important things to note is the TTL, so how long a message will stay in the queue before it's removed from the queue or moved to dead letter queue. You can enable dead lettering down below. You can enable partitioning here. You can set the lock duration. Very similar to what we'll see for PubSub, I think at the subscription level, but there you go. Hey, this is Andrew Brown, and we are taking a look at topics. So topics can be used to send and receive messages. And the idea here is you have a queue, which is often used to facilitate point-to-point communication. And topics are useful in publish to subscribe, so one-to-many communication. So if you want one-to-one communication, you use queues. If you want PubSub, then you use topics. And both these options are available for Azure Service Bus. So topics are not available at the basic pricing tier. You need to have standard or premium. So if you're trying to find that option for PubSub, that's where we're going to have it. And remember that we said that queues use a pull model. Well, topics use a push model. So you don't have to request it, just gets pushed out to you because they're subscribed to it, like having a newsletter delivered to your door. So multiple independent subscriptions can be attached to a topic and work in the same way as queues from the receiver's side. A subscriber to a topic can receive a copy of each message sent to that topic. Subscriptions are named as entities. And so here's an example of sender and receiver. You can define rules on a subscription. A subscription rule has a filter that specifies a condition for a message to be copied into the subscription, as well as an optional action that modifies message metadata. So let's take a look at what the form is for topics. So the idea is you name your topic. You have a max size between 1 to 5 gigabytes. You can have a time to live. So after that period of time, those messages or event data just goes poof. So it's just gone. You can avoid duplication by turning on enable duplication or duplicate detection. You can enable partitioning, and partitioning is intended for scale. So if you have a lot of messages, you might need to partition based on your volume, okay? Let's take a quick look at subscriptions for Azure Service Bus. So I just pulled up the form here because a subscription is just the application that is receiving that information. So you just define one in the interface here, but there are some values that I want to point out, such as max delivery count, which can be between 1 to 2,000. This manage sessions. So with sessions enabled, a subscription can guarantee first in, first out. So FIFO, delivery of messages. So that is where that gets turned on. You can also enable dead lettering here, and you can have a lock duration and adjust that there, which I didn't highlight here, but it's here, there. But we will see these things a little bit closer when we do the follow-alongs. But yeah, a subscription is, an application that is receiving information, getting pushed information to it that it will use, okay? Let us explore the pricing for Azure Service Bus. So they have 3 different pricing tiers: basic, standard, and premium. The more expensive tiers provide more functionality, which I would hope that would always be the case for most services. But on the right-hand side, we have our available pricing, and you can see it's based on a metric, so like MUs per month and things like that, or operations per month. And so here is the chart. So let's take a look at what the differences are. So I highlighted topics in yellow to show you that it is not basic. It's not in the basic tier. You have to have standard in order to utilize that. And for your purposes as a person learning Azure Service Bus, you absolutely need to give topics and queues a go, because queues is the classic messaging model and topics is pub sub. And the only way you're going to do that is by using standard, which we will do in the follow-alongs. But notice in basic, we don't get topics, transactions, deduping, sessions, forward to, send via, no resource isolation, geo disaster recovery, Java messaging support, AZ support. And then some of those aren't supported in standard. But then in premium, we get basically everything. And then notice like the big bump in terms of the message size between basic, standard, and premium. So again, the thing I really want you to remember is that in basic, there are no topics, okay? All right, let's take a look here at dead letter queue. This is just a general concept that is common for messaging pub sub systems and is enabled in Azure Service Bus for both queues and pub sub. But a dead letter queue is a service implementation to store messages that fail to deliver. And common reasons for failed messages would be things like message that is sent to a queue that does not exist, the queue length limit is exceeded, the message length limit is exceeded, the message is rejected by another queue exchange, the message reaches a threshold read counter number because it's not consumed. Sometimes this is called a blackout queue or backout queue, sorry. The message expires due to per message TTL, so time to live. The message is not processed successfully. So dead letter queues hold messages that have failed to deliver. A dead letter queue could be used for things like monitoring failed attempts, requesting requeuing failed attempts, so try it again, or trigger a follow-up action, so maybe a remediation or a response. So very useful feature, but there you go. Let us talk about Azure Service Bus command CLI or CLI commands, because if you are doing the AZ204, the developer, it's very important to know these commands because they may ask you them. So here I have a bunch of example commands. So just quickly looking at this here, we have creating a resource group, creating a service bus namespace, a queue, an authorization rule. And so it's pretty straightforward, you know, AZ, service bus, etc. Let's take a look at some commands we should know, or subcommands, I should say. So when we say command, the command is service bus, and the subcommand is what follows that. So we have ones for geo recovery alias. So we want to set the geo recovery for it. We don't have an example here on the right-hand side. For migrations, for namespace, for queue, for topic. And so on the right-hand side there, we have one for namespace. We have one for creating a queue. But you'll notice here that we don't have anything that kind of manipulates or adds messages to queues. So the Azure Service Bus does not have CLI commands to send messages to the queue or topic, unlike Azure Storage Queue, which I found out, which was kind of interesting. So to send messages to the queue, you need to use an SDK like Node.js, so you'd install it, and then you'd have to write some code. And we do that in the follow along. But I just want you to remember that Azure Service Bus, you cannot send messages to the queue or topics via the CLI. And, you know, that kind of sucks because, you know, if you want to do some easy test, it's unfortunate that functionality is not there. But anyway, that's the difference between that and Azure Storage Queue. So there you go. Hey, this is Andrew Brown from Exam Pro, and we are going to take a look at Service Bus. So what I want you to do is type in Service Bus at the top here. What's interesting is that this is the old icon. They have a new icon. So just realize that there's some inconsistencies there, and that's not my fault. That's Azure's fault. But the first thing we need to do is create a namespace, because a Service Bus is kind of like, you know, storage account where you can have a variety of different kinds of storages. Well, you can have more than one type of messaging system. And so we have our traditional one, like event messaging, similar to Storage Queue, but with first in, first out functionality. And we have pub sub via topics. So what you'll do is create a new Service Bus namespace. And I'm going to create a new resource group. I can call this the AZ204 Service Bus. And we'll say queue, because we're going to do a queue and then we're going to do a topic separately. And for this, I'm going to call the namespace Service Bus Queue to keep it simple. We'll let it launch wherever it wants to launch. And notice there are multiple pricing tiers. Depending on the tier affects the functionality. So if we do basic, we're only going to have access to queue. We're not going to have access to topics. And so this is totally safe and fine to do. Like even if we did premium, it's fine because it's based on your consumption. It's not based on, you know, you just holding around. So we'll get the basic one here and we'll go to networking. I don't think there's anything interesting there. We'll go ahead and review and create, and we'll let that create. Click create again. And it's deploying. As that is deploying, which will not take too long, what I've done is set up a private repository here. You'll probably see me use this throughout the course. It's literally an empty repository because I already have the code done. I've been doing the follow-alongs and documenting them here in the free Azure Developer Associate. But when you're doing follow-alongs with me, you should do them from scratch. And then if you need to, you can reference the stuff here. So I have this separate repository. I have a Git pod account, which has a free tier. You can totally do this in your own Visual Studio Code on your local machine. The reason I'm doing a Git pod is because I always want to show you how to set up the CLI and those other tools. And when you launch Git pod, it gives you a blank environment. So I'm just going to launch that up there. As that's going, we'll go back here and take a look and see if this is ready. Just hit refresh here. It is still going. But we already have our environment. And while that is going in the background, I want to go install the Azure CLI. So we don't even have a single file here. I'm just going to say readme.md so I can see what is going on here. Maybe we'll just dump things in here as we go. I'm going to go get the Azure CLI Linux, because this is running Linux Ubuntu here. So something you should always check is like, what Linux version am I running? If you're on Windows, of course, this is going to be different, but even Windows using the Windows subsystem Linux is using Ubuntu as well. So what I'll do here, I'll go to the first link. Nope, that's not the one I want. Maybe the second one. There's usually like a command here I can run. Which Linux version am I running? Let's try this one here. It's usually like, so maybe it's this here, cat proc version. It really does vary based on what you're using. And so here I'm going to go File, Terminal, New Terminal. We'll paste that in there, hit Enter. And so here it says Linux 5.13, Ubuntu 11, 18. So I know that this is Ubuntu. Yeah, I don't really like that one there. Let's try this instead, because this just doesn't read very well. There we go. We're running Ubuntu 20.04. I already knew that, but I just wanted to double check. And the reason that matters is that when you're installing the CLI, it might matter what version you're using. So we're going to go here, and I'm going to go to Linux, and the instructions might vary. This one says 16, 18, 20, so they're all the same here, and we have this one-liner here that we'll install. And what I'll do here is drop it in here and hit Enter. I'm not sure if this font is too small, so while that's going, I'm going to see if I can bump up our font here. I'm looking for the terminal font size here. Terminal. Let's just say 20 here. There we go. And so the Azure CLI should be installed, so I'll just type in clear. So let's say Azure or AZ to run it. Looks good to me. So we'll type in Azure login. I don't want to log in with, that way I want to log in with device. So we'll do AZ login device, because if you're on your regular computer, you can just click a button and go to the browser, but I'm not going to be able to do that. So I'm going to have to do a device login. Device. Well, I'll have to do it the wrong way first to do it the right way. So hit Enter, because the problem is if I go here, it's going to go to localhost because it's trying to launch in my local machine. So it does that, and that's no good. And so here it says do the AZ login use device code. Okay, so that's the one I really wanted to use. So -- use device code, Enter. And that will give us a code. So what we do is we will need this link here. So I'll have to expand that to here. And then I'm going to go ahead and grab that code. Continue. And so now I go back. This will authenticate. It'll just take a second here. Close the tab here. There we go. Maybe I have to close the tab. And so now I'm authenticated, so I should be able to do whatever I want. What I need to do next is create ourselves a message queue. So we'll go to the resource here. And notice here in entities, it only says queue. Now, if we had, other than the basic, the standard plan, then we would see topics here. We'll go click into queue, click create a new queue. I'm going to call it my queue. We have some options here. The queue size can go up to 5 gigabytes. The max delivery count. So this is the maximum deliveries. Time to live, that is how long they live in the queue before they are dropped out or they are dropped into a dead letter a system there. We have lock duration, so the amount of time a message is locked for other receivers. You can enable partitioning. That's pretty complicated, but we'll go ahead and create our queue. And so this should be pretty darn quick. There is our queue. We'll click into it. And you'll notice that there isn't really a way to view messages. There's not a way to add messages. Here we have the Service Bus Explorer, which I guess technically you can send and receive here. I had not noticed this before, at least it was not working for me. So I suppose we could send a message here saying like, hello world. This literally wasn't here last time I checked here. And we can go ahead and just hit send. Okay, and notice here it says there's one active message and we can receive it. Say yes. And so it says it received the message. It's not showing us the answer. So I guess there kind of is something here. I guess they're still working on it, but mostly what we're going to have to do is do things programmatically. So that is why we have this account. So what I want you to do is open a new tab here, and we're going to type in Azure Service Bus documentation, because we're going to grab some code there, modify it, make it our own, so it's a bit easier to work with. So here I'm in the Service Bus. We'll go to tutorials. I'm not sure if this one is the right one. Azure Service Bus Documentation Queue. It's the same thing here, but this doesn't look right. What is Service Bus? I mean, it is the right page, but it had a couple tutorials here that I had here. So we'll type in like Azure Service Bus tutorial topics. Sometimes things aren't where you think they're supposed to be. Okay, we'll type in Service Bus. Seems like the same page again. It was quick starts. Sorry. So we have tutorials here, and then we have quick starts. So under the quick starts, this is where I was finding the example code that I thought was okay. Notice that we could do everything via the CLI. That is not that fun. But I mean, this only does the creation of it, doesn't necessarily do sending and receiving messages. Notice that we only can use code. So we'll use JavaScript because I think that will be the easiest to use. So I already have Node. Node comes pre-installed on Gitpod. You'll have to figure that out for yourself on your own machine. Or you can just use Gitpod as well, because it does have a generous free tier. What I'll do is go ahead and paste on in this command. It doesn't seem to want to paste today, so I'll hit copy. And then we'll go back here and go right-click, enter paste, hit enter. And so what that will do is install that library. If you're not very familiar with Node.js, package.json is the package manager, and this is showing that this requirement is there. I want to install one other thing called .env. This will make our lives a lot easier for Node. It comes for different things, but I just want it for JavaScript here. So then we'll do npm install .env-save. That's just a safe way for us to pass along our environment variables. And so now both of these are installed. So what we'll do is we'll go back over to this code and we'll scroll on down, and they have one called send and they have one called receive. So what I'll do is create myself a couple files here. So we'll have send.js and we'll have receive.js. And then what we'll do is go ahead and copy, this is the send code. So we'll put this in the send.js file. And then down below, we have the receive code. And we will paste that on in there. So I'll just make this bigger and we'll take a quick look here at what it's doing. So what this does is it imports the SDK for Service Bus. We need to set a connection string. We need to set the queue name. Here is a bunch of messages that we are going to be passing along. Here we establish a Service Bus client. Very common in all SDKs to set up a client first. Then we are creating a sender. And then here we are doing create batch messages. So it's a way of sending messages in batch very efficiently. So we have a for loop here. And so it says there's a batch. And then it says try to add the message to the batch. If it's not, wait until it's ready. Then send the message. Okay, so pretty straightforward for that code. Receive is going to be similar. So connection string, queue name, create that client, create a receiver. And then from there, we will set up a handler for the receiver, an error, and so then we'll subscribe, and we will listen for the message and handler. So even though we are doing queues, it's called a subscription still, so just don't get too mixed up with that. What I want to do is just make sure that we're passing our environment variables in safely, our configuration. So this is pretty standard or good best practices when working with any language. But the idea is you don't want to hard code your values. So I'm going to do process env. And we'll do connection string here. And then we'll do process env queue name. This is the way you grab environment variables in JavaScript for every language. It's a little bit different. Okay. And I believe these are the same. So I'm just going to go ahead and grab that there like this. And I'll paste that on in here. And I wanted to load an environment variable, so I'll make a new file here called .env. This is all part of that env dot thing that we're looking at, env dot. I'm just pulling that up again here, or .env. You gotta get the right one. Because we need this line here, require .env config. That will load the environment variables. It'll load it from that env file. So we will go above here and hit paste. And then we'll go to the receive here and do this as well. And in here, we need to define these. So I'm just going to copy this so I don't have to type it out by hand. We will paste that on in here. And so I just need the queue name. And connection string, we'll just say equals and then equals. So our queue was called my queue. And then we need to go grab the connection string. So I'm just thinking here, this is probably, yeah, it's at the namespace level. And we'll go to shared access policies. Notice it's called shared access policies. Remember when we were doing the storage key, it was like called key access. So it's totally different interface. This is what I'm talking about where Azure is inconsistent. We're clicking on the root manage shared access key. Probably could create your own so it doesn't have full privileges, but for this purpose, we're just going to use this one. On the left-hand side, we have a primary and secondary. We're going to use the primary one. And we will go back here and we will paste on that value in. So I'll paste that in there. Notice we don't have to do double quotations here. It should already escape in double quotations, but when we were doing the CLI, when we did the storage accounts, that wasn't something that we could do. So we have these two values here, so they should get loaded when we use them. And this should all be good. So we'll type in node send.js and hopefully it just works. Fingers crossed. And so it sent a batch of messages to the queue. So we'll go back over to our queue here and see if we can see anything. And we'll click into here. I'm just trying to see. So there's 10 active messages that are here right now. And so what we'll do is we'll receive all those messages. So we'll go up and hit node receive.js. And so this code is now receiving those messages from the service bus queue. And we're just going to wait here because it takes time for whatever reason to finish here, but we'll give it a little bit of time here to figure out that it's done. Still waiting. There we go. And so that's all there really is to it. So that is queue, and we will do this again, but next time with topics. So what I want you to do is make your way over back to your resource groups. We'll find the one that we just created, which was this one here, AZ204 service bus queue. We'll delete this service group. Hit delete, delete, and there you go. And as always, double check to make sure that you've for sure deleted that stuff. And that's it for service bus queue. We'll do topics next, okay? Hey, this is Andrew Brown from Exam Pro, and we are looking at service bus, and this time we're looking at topics. So what I want you to do, just like before, is go to the top. We'll type in service bus, and we'll go to the service bus service. You can still see the old one is there. It should be deleting. That's how slow this thing is. But we'll create a new one. And we will create a new resource group, and we will call it AZ204 service bus topic. We'll say OK. We'll name this service bus topic. And this time, it already exists. And if it does, just dump a bunch of numbers here on the end because it's unique based on that. So it's like having a domain name. If somebody already has it, you're going to have a problem. And so here I'm going to go to standard because in order for us to use those additional features, we will need to be on the standard plan. So we'll go ahead and hit review and create. And that'll take a little bit of time to create. But while that's going, I'm going to launch my environment here. So this was the one I was just using a moment ago with GitHub. And so what I'm going to do is I'm just going to go back to our repo here. I'm just doing it off screen because I don't want to expose all my stuff here. And again, if you want to, you can do this in your local Visual Studio Code. I just want to show everything from scratch every time. So here's my empty repo with git pod. And so I'll just close this one and it will vanish. All that code is now gone. I'll hit git pod. This will launch a new environment. It's trying to tell me to open the last one. Nope, I'm going to make a new one for this workspace here. And we'll get going here in a moment. So this namespace has been created. So we'll go ahead and hit create. And I guess it's still making. I thought I already deployed it there, but I guess I didn't. Okay, while that's going, we'll go ahead and install the Azure CLI. So we'll type in Azure CLI Linux, because that is what we're using here today. We'll go to Linux here. We'll scroll on down, grab this one-liner here to install it. I'm going to open up my terminal. Your terminal might be somewhere else. Allow. I'm going to go ahead and paste that on in there. That's going to install our Azure CLI. As that's installing, it'll be done here in a moment. Let's see if this is done. This is still creating the namespace, I think. And this is still installing. Shouldn't take too long. While this is going, we can start grabbing the code for this. So for this, we'll type in Azure, Azure Service Bus Documentation. And this, I found it under the Quick Start. So we will go to Quick Start, Topics and Services, because there's some code here that I want under the JavaScript. And we have one for send to topic. So we'll just grab that name there. Make a new file, send to topic.js. And we will go down here to this other one. This is receive from subscription. You're going to notice this is very similar to doing a queue. The difference is that you can have multiple subscriptions consume the same stuff. Our CLI is done, so we'll type in AZ login. I can't remember what it is, so we'll hit enter here. I know this is the wrong way, but I just can't remember what it is. I want use device code, that's what it is. So I'll go ahead and grab this, and I'll just hit Control-C to exit out of that, and then paste that in there. And then we'll do it the way that we actually want to do it. So then we will go ahead and grab this for device login. We will provide the code as suggested here. We will hit continue. We will close this. And it will say that we are authenticated. So we are now authenticated. We can use AZ or the Azure CLI. I don't know if we need the CLI. Well, we have it anyway. At least we had to authenticate, so at least that was out of the way. I'm not sure if we're actually going to use the CLI in this one. But what we'll do is go to the resource here. And we want to create a topic this time around. And I'm going to call this my topic. We have a topic size between 1 to 5. You have a TTL. You can do make sure there aren't duplicates. We're going to go ahead and create this topic. Okay, so just like last time, we need to install a couple things. So if we go to the top here, there should be like an npm install. Here it is, npm install service bus. So we'll paste that on in there. We'll need our .env, so look up .env again, and we will just install npm install .env for environment variables. Hit enter. We'll create ourselves a new .env file. And we will need to look at what environment variables we are going to need. So it looks like we didn't copy the send to topic content, at least I didn't. So we will go back over to here and go up here and get send to topic. Paste that on in there. We'll go all the way to the top, and I'm looking for what we need here. So here we have one which is connection string. Whoops. Did not mean to delete all that. So we'll hit process, env, connection string. And we have to spell it right or it's going to have a problem. And then we have process env topic name. And I think in this one it actually also has subscription, so we'll have to have a third one. So I'm just going to copy these two over, so I have to type it 100 times. And this one will be process env subscription name. You're noticing I'm not having the semicolon. That is optional in JavaScript. So it won't break anything if I don't have them there. Subscription name. And so these are the three that we'll need. I'm going to just split this to make my life a little bit easier. And I'm just going to copy this here, paste. Not exactly how I wanted to paste it, but that's totally fine. I'm going to copy this. I don't think we made a subscription yet, but I know we're going to call it my subscription to make our lives easy. So we'll say my topic, my subscription, and we'll grab this in a moment. So we'll go back over to Azure. We got too many tabs open here. While we're here, we might as well go grab this code before we go back to Azure. So I'm going to grab this .env config. That is going to load our configuration environments. So we go to the top here, paste that on in there for both files. Again, best practice never to hard code your values. Always pass it in like that with environment variables. We'll go back to our service bus. The first thing we need, well, we made a topic, but we're going to need a subscription. So if we go to topic here and click into it, we can create ourselves a subscription. So we'll go here. We'll say my subscription. Notice we have max delivery count. We have to set this between a value of 1 and 2,000. I'm going to say 12 for fun. We can set the idle. Notice here, if we want to have first in, first out, we would checkbox enable sessions. We're going to leave that alone. Does not matter too much for our demo. So we'll go ahead and create that subscription. It is created. Now what I need you to do is go back to the service bus topic namespace. And from there, on the left-hand side, we're going to shared access policies. We're going to click into the root manage shared access. We're going to grab the primary connection string key. The secondary would work too. It's just a second optional one because they always give you a 2. We'll paste that on in there. And if this is all correct, these should just work. So now what we'll do is type in node. Actually, we did want the CLI installed because I wanted to show you that there was stuff in the queue, whereas with storage queue, when we're doing Azure Storage Queue, I couldn't show you because I just didn't know of a command, I believe. At least I think that was the case. But anyway, we'll take a look and see what we can see, okay? So, actually, we didn't do it at any time. I wonder which one I did that for. Let's just double check here. I have off screen here somewhere my instructions, because I wrote it for one of these. Maybe it was for the queue that we did it. Yeah, I didn't do the last one, but I did an Azure Service Bus Queue show, and the idea was to show you that there was a message count 10 so you could see the queue. But I think that since we saw it in the UI, I just wasn't too worried about it. Now, did I do it for this one? I'm not sure. Yeah, we do a topic show, so we'll do that for fun. But first we need to insert our messages, which are part of the topic send. I don't think we read through these, so let's just quickly read. They look very, very similar to the last one. So you have your messages that you want to send. You create yourself a client. You create yourself a sender. You create a batch message, send message. Like, it's basically identical. Like, I can't even tell the difference here, except here we're supplying a topic name. So, I mean, I see it here. Here, create sender. The topic name is specified there. So I just imagine that instead of providing a topic name, you provide the queue name, and that's how it knows the difference. But anyway, what we'll do is go ahead and execute this code. We'll say node send to topic JS. Okay, so it sent the stuff. Now, we didn't do this last time, so let's do it this time around. So we'll type in Azure Service Bus, topic show. And here we'll need to set the resource group. So this was called, I don't know, let's go take a look here. What is our service group called? It is called AZ204. Bring that down a bit here. AZ204 service bus topic. We need to specify the namespace name. So that's just called service bus topic hyphen 723849 because we couldn't get the number we want. And then we need to specify the name. So I assume it's the name of the topic. So the top is my topic, and I'll hit enter. And it says service bus name is misspelled or not recognized by the service. Did you mean service bus? Yeah, I gotta spell that right. Hit enter. And that looks fine, but I just want to specify it as output YAML. Just hit up on your keyboard if you want to go back to those previous commands. We'll hit enter. So this is a little bit easier to read. And so what we're looking for here is just kind of like the message count. Does it show us here? We see subscription count. I don't see it. So I guess it's not visible in the same way as the queue is. Like if we did this and we didn't do it in the last one, we just saw like that message count there. But let's take a look at what we can see in the CLI to just see what information, or a UI that or portal, so we can see some information here. So we have one subscription here. We'll click into here. We have max size, incoming request 12. Yeah, I don't really see it. Message count 10, max delivery count 12. Okay, so I guess there was 10, and that's the 12. So I guess that's where it's being counted. Let's go run the other one to receive. And I'm going to just double check to make sure that we set those. We did. That's all good. So we'll type in node receive. If you're wondering how I'm auto-completing without typing that, I just hit tab on my keyboard. So it's receiving those. Good. And that finish, I'm going to go ahead and refresh, see if there's any difference here. Notice that the message count is 0. So when the topics were there, it was held in the subscription saying 10 is here, and they've yet to be delivered. When we ran it, they were received, and so that number cleared out. That's all we really need to learn for topics. So we are done with topics. So let's make our way over to resource groups. And we'll go over to our service bus topic. We'll go ahead and delete this here. Delete. There it is deleting. We are all good to go. And, you know, just as always, don't ever trust Azure to delete these things. Come back and check in 3-4 minutes. Make sure it's deleted so you just don't have things lingering around. Yeah, there you go. All right, let us compare Event Grid, Event Hubs, and Service Bus because these all are event-driven services for application integration and use event buses as a means to work with event data. But it gets confusing because I guess you could say they all have overlapping responsibilities. So let's kind of clear that up. So we have Event Grid, Event Hubs, and Azure Service Bus. So the idea is that Event Grid is a serverless event bus. And I would say that you'd probably want it for Azure service-to-service communications. The idea is that you just have, let's say, you're like integrating from service to service. So you're not deploying necessarily fully custom web applications or traditional applications onto virtual machines. It's more for like cloud native, cloud first kind of builds. They're dynamically scalable. They're low cost, at least once delivery of a message. For Event Hubs, this is streaming data, so we get low latency, can receive and process millions of events per second, at least once per delivery of an event. And streaming, because of the nature of it, is generally more expensive than traditional things like a queue or a pub sub for web applications, which is what Azure Service Bus is. So reliable asynchronous message delivery that requires polling, and I guess pushing technically for pub sub. Advanced messages features like first in, first out, batching sessions, transactions, dead lettering, temporal control, routing, filtering, duplicate detection, at least once delivery of a message. So it really sounds like, and there's one option here, optional order delivery of message. So it sounds like Azure Service Bus has it all, but really it's not at the same scale as Event Hubs, and it's not at the same level of hands-off kind of approach that Event Grid gives you with serverless. But you have all those options there, and you will use them all. But there you go. Hey, this is Andrew Brown from Exam Pro, and we're taking a look here at the introduction to Redis. So what is Redis? Well, Redis is an open source in-memory database store, and it acts as a caching layer or a very fast database. It has a lot of utility, but those are the two most common. And one thing is that because it's in memory, that data is highly volatile. So there is a chance of a data loss. So even though it is super fast within milliseconds, like 5 milliseconds, 10 milliseconds, it's not used as a primary database, but, there are tools out there that have made them more durable. So it really is up to you. But the other thing about Redis is that it's a key value store. So it's not like using a relational database. And so it has its own type of data structures, data types. So we have strings, sets, sorted sets, lists, hashes, bitmaps, bit fields, hyperlogs, geospatial indexes, streams. And the ones in red, I do want to go over with you because I think they're worth your time. But the idea is that to use Redis, you're either going to use like a programming library. They're pretty much available in every language. Or you could use the Redis CLI. So getting my pen tool out here for a second. Here you can see we're logging to the Redis CLI. We're doing a ping to the server. It gives back a pong. And here we're setting a simple key value. So we say my key, some value is the string we are setting. And so it is that simple. It's a very simple database, but it's super, super fast. But let's take a look at some of those data structures or data types so we can see how we're going to interact with this database. All right, let's take a look at our different types of data types, data structures that we have available to us in Redis. The first is strings, the most basic one, the most important one, because everything is basically strings at the end of the day here in Redis. Strings are binary safe, so they can contain data such as JPEG image, serialized Ruby objects. So they can represent different things. They can represent numbers, which is kind of odd. And strings have a max length of 512 megabytes, so you get a lot of room there. Often you're doing a get and a set here, so you say get, get this key, and you get back that string, set this key with that value. So very simple to use. Strings can represent numbers, and so now you have these special functions for strings called atomic counters. So you can do things like increment, decrement, increment by a certain amount. So very, very clear here. So notice it is a string, but we can increment it and now return 11. And it interprets it as an integer, which is interesting there. So the most common string commands would be things like get, set, append. Append would just add something to the end of the string or check if a string exists based on a key. So exists. You have lists. So lists are ordered collection of strings. They're not going to give you a guarantee of unique strings or unique elements within that list there. So you can have duplicates, but you do things like lpush, lrange. It's kind of like having an array in other languages. Here they're doing a range. Notice it does -1, but it actually returns all of them. So that's kind of a trick there to get all the elements in a range. But you could say like 1 to 2, and then it would just return 1 and 2. Common commands for lists would be lpop, rpop, lpush, lpos, which is for position. So lpop would remove the last element and return it, or on the left-hand side. So the first one, rpop would be on the right-hand side. So if you did an lpop, it would return hello. If you did an rpop, it would return world and also remove it from the list. Lpush would add a new thing on the end. Lpos is for getting a position. So you provide a string, it'll tell you its position in the list. Then you have sets. So seems like they're like lists, but they're unordered. So there's no guarantee that if you request the stuff in the list, it's going to be in the order that you expect it. But the advantage, though, is that things are unique in the list. So if you push the same thing, if you add the same thing to that set, like world twice, it'll only be there once. So that's when you need a unique amount of things in a collection there. Most common commands here is sadd, so add a member, smembers, show us all the members, smove, move a member from one set to another, spop, similar to rpop, like what we saw with list. So just remove the one or multiple random members from a set. We have hashes. So hashes represent a mapping between string fields and string values. Redis was originally coded in Ruby, so they're basically like Ruby hashes. But if you don't know Ruby hashes, there's JSON objects. You've probably seen those before. Ruby hashes, of course, Python dictionary. So the idea is that you say, okay, I'm making a hash. I'm going to set a field, which is just a key. It's string, field 2, and its value there. So pretty straightforward. Common commands for hashes would be like hget to get a value, hdel to delete a value, hmset to set multiple values, hmget to set or to get multiple values, hvals to get only the values, hkey or probably keys to get only the fields, which are keys in this case here. We have sorted sets, so these are similar to sets, but they have an associated score. So when you add something, you use a zadd for this, but you give it a score like here, 1, 1, 2. And these are really great for leaderboards or where you need to score things and sort that way. So common commands here would be things like zadd to add something with a certain score. Zrem is for removing. Zrange is when you want to return a range of elements in a sorted set score. Zrank would be return the rank of a member in the sorted set score. Set sorted, so it's not giving you, I said stored, but it's sorted, so it's not giving you its score, it's giving you where it's ranked within the list. And then you have Z score, and so that you provide the value, and it would tell you what its score is. So those are all the data types that you should get some hands on with. There are some interesting ones like stream and things like that, but This is pretty much the core stuff for Redis. Redis is not hard to learn or use, so you just got to jump in there and use it, okay? All right, so we just took a look at Redis. Now let's talk about Azure Cache for Redis. So Azure Cache for Redis is based on the popular open source Redis cache or data store. It gives you access to secure, dedicated Redis cache that Microsoft manages and that you can access from any Azure application. All major cloud service providers have a managed Redis service or database because it's just super useful. And we'll talk about the use cases here in a moment. Azure Cache for Redis is suited for high throughput and low latency requirements where the same data is often requested. So remember those key 3 things to know when you're supposed to use Redis. There are serverless databases, like NoSQL databases, that can operate extremely quickly, like with a guarantee of a certain amount of time. But Redis is just like super fast. It's faster than everything else out there because it's in memory. Azure Cache for Redis is commonly used for these scenarios, and I really do want you to pay attention because these are very common, very practical, and as a developer, you really should know these. So a very common use case is storing session data. If you have a web application and it's deployed to multiple virtual machines, a hard part about having an application running across multiple virtual machines or containers is that knowing what was the last, like where the session is stored, the actual state of a user. And so you can't have it running on one virtual machine because then the other ones won't know about it. So you need to store it somewhere else. So Redis is a very common use case for that. Storing cached HTML or JSON. This is a very common use case to speed up response times. Another thing that we normally see would be MemDB. It's another caching solution specifically for HTML. Yeah, this is something you'd put in front of your web application to speed up web pages or API calls. Another one is a job or message queuing system. If you are in the Ruby on Rails world, a very common queuing system is called Sidekick, and it uses Redis. Or another thing, again, in Ruby on Rails, if you want to use Action Cable, which is for doing pub sub, like real time, like building a chat, like a chat system or a game, that's backed by Redis. So those solutions aren't going to change. You can usually use Redis for those things. Another one is using it to be in front of a database to reduce read contention. Read contention means like too many reads are hitting the database, so it's slowing everything down. So you can put a cache in front of that to improve response times for fetching data, to just take the load off the database. Maybe you have a database that's expensive to call, so it's going to save you money. And so you can put this in front of CosmoDB or Azure SQL, very common cases, or any kind of database really that returns data. And so this is actually called the aside cache pattern, something you want to kind of remember, where it's going to sit in front of the database. So if the data is up to date and it's there in the Redis store, it'll take it from there. If not, it'll go to the database. And the database can be proactive and send data to Redis so that it doesn't have to do a hit or miss. It can just have the data there, it knows that it's there. Just to kind of visualize this, just to see where those are. So I'm just going to get my pen tool out here. So the first is like where Redis or Azure Cache for Redis is sitting between your application and the request. So maybe you're hosting on Azure App Services. But the idea is that before a request makes it into your application, it's going to check that cache. And so that can reduce the load on your application, improve the load times if there's things that are computationally expensive. Then there's your database. So over here, between your application to your database, it's going to hit the Redis cache first. If there's data, it will return it. If there's not, it will go straight to the database. And then the other common use case here is to have a fast database for real-time data, maybe for queuing, jobs, video games, leaderboards, things like that. So yeah, that's pretty much it for Azure Cache for Redis. Just got to get some hands-on experience with it, but very simple, not too complicated, very useful.